Hello grade 12s, welcome to my channel. Let us revise on Euclidean geometry. This is going to be very good for those who are doing the May-June exams. But for a grade 12 of 2026, this is also going to come in handy during the mid-year exams. So stay put, see how things are done, and if you guys are interested in this document, it's going to be in the description below, as well as the memo that I am trying to compose. All right, folks. So we're going to start with question 1. Now, question 1 says, in the figure below, triangle ABC has D and E on BC. And we can see that those are the points on BC. BD is equal to 6 centimeters. So this is 6 centimeters. And DC, this length is 9 centimeters. Okay? And we're told that AT is to TC. AT is to TC is 2:1. So we can say this is 2x and this should be x. Okay, we never write 1x. Now always choose a multiple, because in a ratio it doesn't mean it was 2 meters against 1 meter. It could be anything. Okay, right. Now, we are also told that AD is parallel to TE, so we can see that. Now, folks, we know that this is essentially going to be a question on the proportionality theorem. So 1.1 says, write down the numerical value of CE over ED. CE over ED. So that's what we want. Now, this is very easy, because what we need to look at is this triangle. Now, if we look at this yellow triangle, you will see that this line is drawn parallel to the third side of this triangle ADC. Now, this means we can use our proportionality theorem here. So let's see. We know that in triangle ADC, always try to highlight the structure that you are working on. We know, folks, that CE divided by ED must be equal to CT divided by TA, right? And this is because of the proportionality theorem. We just say prop theorem, and we mention that TE is parallel to AD. Remember, the proportionality theorem only applies when one line is drawn parallel to the third side of a triangle, cutting the other two sides in the same proportion. So this implies that we've got CE over ED equaling CT is x over 2x, and of course the x divides the x, because we wanted the numerical value here. Therefore CE over ED is going to be a half. Obviously, folks, the question was very clear. Write down, meaning all of this is what you think about in your rough work. We don't want to see it. Okay, this becomes the rough work. This is what you do on the side. We want an answer only, no explanations. So obviously, how would you have known? This would have been your yardstick. because if you look at those, they are in the same proportion under the proportionality theorem. Okay, guys, so very easy. 1.2. I'm just showing you how to work it out, because this may be for more than 1 mark sometimes, but I'm going to highlight what you need to do and how to respond to the questions, although I may give you a clearer view of how it is expected to be solved. Now 1.2 says, show that D is the midpoint of BE. Right, so if we want to showcase that D is the midpoint of DE, so this means, of BE, it means we need to prove that BD is the same as DE. Okay? So that's what we need to prove. But perhaps the way I am doing it is not going to be quite clear. So all we need to know is to prove that BD is the same as DE. So that's how we can do that. Okay. Now, folks, we have been given the actual units of DC. So this means we can use that ratio we just did above to then sort out what the value of DE is. For we know that DE is going to be how many? 2 portions, because DE and ED is the same thing, right? It's going to occupy 2 portions of how many? We add these two. 2 plus 1 is 3. So this is going to be 2/3 of DC. Again, guys, you need to know how to work with ratios and proportions. So DE is going to be equal to 2 over 3, and DC is 9 centimeters. Now, 3 goes once to itself and twice to 9. So this confirms for us that DE is basically, did I say 2? No, 3. Now we can see that it's just 2 times 3, which is 6 centimeters. Now we can say, therefore, DE is equal to BD. Therefore, D is the midpoint of BE, right? Because we can see BE is 12 units, essentially. One can see that, and essentially this means D must be the midpoint of BE. Okay, guys, it's as simple as that. So please know how to do ratios and proportions. So we get 2 marks for the substitution there, and we get the answer, because that's what matters. The conclusion was already made for us. We just had to show how we came to it. Okay, so very easy stuff, folks. Not a complicated question. So these are easy stuff. 1.3. This looks familiar anyway. I think it's one of the past exam questions I've done in the channel, perhaps as part of some exam or so. Let's have a look at 1.3. It says show, It says if FD is equal to 2 centimeters. Okay, where is FD? This is FD. So FD is this part, okay? If FD is 2 centimeters, right? And we need to calculate the length of TE. So the question is on TE, okay? So obviously, guys, this is not a very difficult calculation to go about. We just need to know how to look at this, okay? So the best way to look at this is to focus on this triangle. So what we note in that triangle, BET, okay? So we will say that DF is drawn parallel to TE. And we happen to know the units of BD, 6 units. And we now know BE is going to be double that 6, which is going to be 12. So we can use our proportionality theorem in this. So we will say in triangle BET, what will we say there? We know for a fact, folks, that what can I say, DF over TE should be equal to BD over BE. Okay, so that's the most important, and technically this uses the concept of similar triangles, but here we are going to use our proportionality theorem. So this is prop theorem, where we see that FD is parallel to TE. Okay, now we substitute. How you start these ratios doesn't really matter as long as you're consistent and you're doing the right thing. So DF is 2 centimeters divided by TE, that's what we are interested in. BD is 6 centimeters, it was given, and BE is going to be 2 times 6 because we saw that D is the midpoint of BE. Okay guys, so let's get to business. Now all we have to do is to cross multiply and solve. So this implies that our TE is going to be 2 into 2 into 6, all divided by 6. And you can already see that 6 and 6 will take each other out, and therefore TE comes up as 4 centimeters. Nice and easy. Now, why is it so? Have you noted that this is double the value of essentially of DF? It's because of the midpoint theorem from grade 10. You could easily have chosen to use the midpoint theorem without really, going about it the long route. So if you chose here, for example, so can you see, no matter how you do it, you're going to get it right. You could easily have said TE is going to be 2 times TD. And then you're going to say midpoint theorem. Right. Because we've already specified that we're working in this triangle. In this triangle, we can see that D is the midpoint. So this automatically tells us that that side, F, is the midpoint of BT using midpoint theorem of triangles. At this point, we just say midpoint theorem. And of course, we go on to solve that our TE is going to be 2 into 2. Therefore, TE is nothing but 4 centimeters. So as you can see, some approaches are much shorter. Some approaches are actually longer. But this just says you need to know. You just need to know. So obviously, guys, for the statement and reason, we normally give a mark, and for the answer, same here, statement and reason, we give a mark. If this was 3 marks, we would talk about substitutions. At this point, we may not give. So don't get hung up onto that. But I can emphasize to you guys that substitutions is something that should be second nature, and there's no excuses for not doing it. So you've got to do it, okay? Because you never know when it's going to help you and when it's not, especially if you cannot finish the question. Okay, so let's look at 1.4. It says calculate the numerical value of the area of triangle ADC. Okay, ADC, the yellow triangle, divided by the triangle of, the area of triangle ABD. So guys, we're comparing the yellow triangle and this dirty triangle. I don't know what color this is, light brown, whatever. Now we need to think, how are we going to do this? Because we need some things to be common. And you can see it's just one mark to suggest that there is not a lot. There is not a lot. So what can we do here? Now remember, if we were to construct a height for one triangle, it automatically becomes the height for the other triangle. Okay, let me just make a vertical line so that I can take it and bring it where I need it. We take it to where we need it. So folks, we can see that if we make this, but I think it's not really giving the things that I want. This has to be perpendicular to, but I don't know why I'm not able to start properly. Okay guys, so there it is. It's much better. Maybe I can move it a bit. Move Galoki. Right, now there it is. Now folks, if we drew a perpendicular height here, would you appreciate that this height is for the light brown triangle, but at the same time this is a scalene triangle, the yellow triangle. It's a scalene triangle, so the height would be the same height outside the triangle, as you would have learned in grade 9, that the height of a scalene triangle is actually outside the triangle. So this means now there's also a theorem, or should we say it's a corollary in grade. Is it an axiom? Sometimes I forget this. Is it an axiom or corollary? Corollary. It's a corollary. We know that when we're evaluating the ratio of two triangles that have the same height, technically that ratio is going to be the ratio of their bases. So of course I'm going to just show you that this is one mark, meaning we just know that they would have the same height. As a result, the ratio of their areas is going to be effectively the ratio of their bases. But I want to show you this. How did it come about, so that you know? So we know that area of triangle ADC divided by area of triangle ABD. This is going to be equal to, we know that we're going to say half the base of the other triangle is going to be DC, right? And then times the perpendicular height, which is going to be H. This is all divided by half. The base here is going to be BD times the perpendicular height H. And of course we would say let the height of triangle AB what BH, if we are going to have to explain. But we don't necessarily need to. You see, the half divides the half to 1, the H divides the H to 1. Now look what happens next. We end up with just DC divided by BD. Is this not the ratio of their bases? It is. And then of course we do the stuff. DC is 9 centimeters. We don't need the centimeters, divided by BD is 6. So 3 goes 3 times there. and it goes 2 times. And that's it. That's all we needed. Of course, guys, what was needed from you as a student, most likely, of course, we can write here this thing multiple times. I don't have the time, right? This means if you came up with this area of triangle ADC divided by area of triangle ABD, an answer only was good enough, okay, for 1 mark. But always try to figure out what was the instruction. Calculate. Does this show that you have done a calculation? Not necessarily. It's like you are copying or you're thumb sucking it or anything. So perhaps this is what would be expected if at least you didn't want to go through the long thing. This is good enough. Because first of all, we know that when we've got 2 triangles and we want to look at the ratio of their areas, it's going to be the ratio of their bases when those 2 triangles have the same height. So this would be good enough. We need to see that, and then the simplified, then it shows that we've done a calculation. But at the same time, guys, don't get hung up too much into easy stuff. Just do everything. Even if it's for 1 mark, you can show the entire calculation from start to finish. There is no excuse for not doing it. But this is just to suggest that at the time this document was given, students were expected to not provide, lengthy explanations for this, but get to business. Of course, guys, this was 1.4, this is 0.1. Again, pay attention to the labeling, folks. It catches you out in the exams. Now let's do the last one. The area of triangle TEC. Now where is that triangle? Okay, so there is the triangle TEC divided by the area of triangle ABC, the big triangle as a whole. Okay, cool. Let's see. How are we going to do that? The one thing that we can see straight up is that they have the same angle here. So this means always whenever you have to evaluate these ratios, try to look for something common. If it is not the height, it has to be a side. If it is not that, it has to be an angle. But something has to be common. And there's 3 things you always look for. Are they having a common angle? Yes, no. Do they have a common side? Yes, no. Do they have the same height? Yes, no. And in fact, it has to be like that for us to be able to work problems in this scenario. Unless we have enough information to evaluate the entire area of each individual if they don't have anything in common. So whenever 2 triangles do not have anything in common, try to see is there any other structure that can link them, maybe another triangle. If not, they're totally different, totally separate, then it means there must be enough information to calculate the individual areas for each, and then later on we can do the ratio. But most likely there's always a structure that can combine the 2. Either a triangle to which their areas can be represented by, so that we can have a nice ratio, or we have something in common in the 2 triangles straight up. Anyway, let's get to business, guys. We're going to use the area rule, grade 11 stuff. So we know that area of triangle TEC divided by area of triangle ABC is going to be, again, area rule is going to be half times. Now, the product of the 2 sides that include the angle is going to be TC times EC or CE, whatever you want to call it, times the sine of the included angle C. This is all divided by half times, for the big triangle ABC is going to be AC. Doesn't really matter which one we started with. At this point, a product is commutative, it can move around. So times BC times the sine of angle C. Now the nice thing is that that angle C is the same angle. So the sine divides the sine to 1. The half divides the half to 1. And look what we end up with. We end up with TC times EC divided by AC times EBC. Now again, this goes on to tell you that if you've got two triangles that have the same angle or common angle, now using the area rule, we can already see that the ratio of their areas is going to be the ratio of the product of the two sides that include the angle. You see that? Yes. Now TC is X. Okay, I leave it as such. And then into EC, we saw that EC, if this is 9, okay, and we saw that this is 6, then this means it must be 3 centimeters. But we can show that this is 9 minus 6. We show that actually we performed a calculation, but instead of doing it separately, we can just showcase this easily. Now we've got AC, which is going to be 3x, we just add all of those up, times BC, this is 9 plus 6, this is going to give us 15. Again, you can show that this one was not nicely given. You can just say this is 6 plus 9 to showcase that actually this was a calculation. Right, so we've got here 3x divided by, and of course we've got 3x into, this is going to be 15. Now already guys, we have a nice situation here unraveling itself, and we've got 1 over 15. Okay, so that's as simple as that. Alright, so as you can see, very easy stuff. Again, here we were getting a bit of marks because we needed to be a bit smart. So using the area rule, we get our marks. You know, the calculations that got involved in here, we didn't just simply substitute. We essentially did some calculations and for the answer. And of course, guys, that would be the marks for that question. So this is 3, 4, 4, 6, 8, 9. So this is the 9 marks of this question. Nice and easy. Okay. So Euclidean geometry, guys, you need to take a bit of time when you're doing it. It's not your typical algebra where you jump in and then see how it goes, you know. Oh, this tea is nice. Actually, I'm trying to stop completely drinking this thing called tea. I see that it has messed up my teeth. At least they've recovered now. Now I need to not go back. It's just that I'm hungry. But yeah, I did not cook. Now, question 2. Let's treat them as questions. So question 2, guys, we're still continuing. Once you see these structures, you know that this is going to be the proportionality theorem. Okay, again, it looks familiar. So let's see. In the figure below, GB is parallel to FC. So GB, where is GB? GB there is parallel to FC, and we can see that parallelity. And then BE is parallel to CD. So BE parallel to CD, and we can see that parallelity. Nice. And then we're told further that AC is equal to 6 centimeters. Where is AC? So this side. AC is 6 centimeters. And then AB over BC. Now we need to write this as a ratio. So even though they're giving it as a single number like that, we know that a rational number like that is nothing but itself divided by 1, and we need this. Because if we don't do this, we will not be able to evaluate this. AB. So this means AB over BC is 2:1. So this means this is 2x, and then this is x. Okay. Normally with these kinds of annotations, you don't need to provide explanations. You just do it, okay, to simplify your life. But at the same time, you may want to state something, but it's never necessary. Or should I say it's usually not necessary. All right, so we have something. Now we're ready to do this. First says calculate with reasons. AH is to ED. So this is AH, right? AH is to ED. Okay, so these ones don't look to be connected to each other. So already the mark allocation is suggestive that we're going to need two equations that are separate, and then maybe work out our way, or we can work out something from one triangle, then work it out in another and see what happens. But if I'm looking at this, you know, I can already see that technically this side AC actually does accommodate well this triangle AEC or ACE, as well as triangle ACD, because there's those parallel lines. So now let's have a look at those triangles. So you will see, guys, that this red outlined triangle has EB parallel to, you know, DC. Okay, we can use that perhaps to get ourselves moving. And if we look at this triangle, you will see that again we can use that to get somewhere. But what is important is that this can define this side EH, because in each case we can have EH over there. So it can help us to move around with some ease, okay? Or if it goes to a push and shove, we can find another way. Of course, guys, this one is one of those questions where you just cannot jump in. You have to think outside the box. Now let's first start with our light blue triangle. We can say in triangle, let's see, we've got ACE. What can we see there? In triangle ACE, we will see that essentially AH, which is what we want, or we may not necessarily be looking for that, AH divided by HE. This should be equal to AB divided by BC. Now what have we done here? We used our prop theorem with HB parallel to EC in this case. Right, we always try to be specific to a particular triangle. Now this implies that, look, what we're interested in more than anything is to find, maybe let's just say we want to find AH, okay? I think it would make sense to say that. Or maybe we look for HE. Okay. Let's go. Even if we look for AH, it's still not a big deal. So we cross multiply here. Now once we cross multiply, what do we get? We get AH times BC is equal to AB times HE. Right. Now, you know what, I'm thinking now we have a bit of a problem. Maybe I rushed. We don't need this. Let's not rush, guys. Let's substitute. As you can see, I'm thinking as I'm moving around here. AB is 2x, we said, divided by BC, that is basically x. Okay? And then, of course, we know the x and the x goes. So we end up with AH over HE equaling 2 over 1. Maybe we can leave it here. Why not? Why not? We can. We should. Okay, so something makes me a little bit unhappy though. Something makes me a bit unhappy. Something makes me unhappy because I'm thinking of two methods to solve this. Anyway, we can say here likewise. Let me see if I do that. Let's just skip a moment here and say likewise. Now this time I'm not going to be stating in triangle so and so. I'm just going to jump in and say, well, I know that AE over ED is going to be equal to AB over BC. Now this is the red triangle. I'm using the prop theorem with EB parallel to DC in this case. Right, let's just move on nicely. AE over ED is going to be equal to, now AB is still 2x over x. Right, so the x takes the other x, and we end up with AE over ED equaling 1 over 2. Now I'm thinking these two are essentially equal. You know, AH over HE is equal to essentially AE over ED. Can you see that? And we've got what we want. So we can equate the two and say then, sometimes this is more marks than you can see allocated here. So we can easily see that, well, AH over HE is equal to AE over ED. I mean, each is equal to 2 over 1, isn't it? That's what we got. That's what we got. So now what do we want? Well, what we want is to the way I started, I feel like I'm going to regret. You know what I should have done? What I should have done was to define ED. Okay. Part of me is screaming as I see this because this is not gonna do good. It's not gonna do good at all. But let's see what happens. Sometimes we know maths enough to get ourselves unentangled. This is divided by HE, guys. We can see there that this is AE minus ED, right? Yeah, so if we take the whole length of A, okay, wait, what did I say? I said HE. HE is actually AE, yeah, minus AH, excuse me. Yeah, that's the one I wanted to say. And this is equal to AE over ED. Okay, nice and easy. Now let's see, we cross multiply and see what happens. When we cross multiply, we're gonna get AH times ED is equal to AE into AE minus AH. We move on. Now what do we have? I think this one is failing. Yikes, this is so terrible. It's actually failing. Damn. I am not happy. Let's see. So we end up with AH times ED equals AE squared minus AH times AE. Okay. This is not AA but AH. Right, so what can we do here? Well, this one is bad. Huh? This one is bad, guys. It's not gonna work. Now I'm thinking, if we go back and say, well, we want to know AH is basically 2 times HE. I think we need that. You know? I think we needed that. I think so. And then we now need to find something. I think that conclusion was needed. Now let's see. We already know AH in terms of HE. Now I think we need ED here in terms of HE. So let's forget about this. As you can see, sometimes your strength is not good enough because if the plan is bad, it's just a bad plan. Okay, so let's see, guys. This means essentially 2 times ED. When we cross multiply, it's going to be equal to AE. Right? Right. Okay. AE is 2 times ED. All right. Okay, all right. Now I want to see something here. I want to see something. Now we want to show ED in terms of HE. Okay, so let's go for it and say, fine. This means ED, 2 times ED is, what is HE? Sorry, AE. AE is essentially AH times, not times, but plus HE. Okay? Yikes. I don't want AH in there. AH is not allowed in there. Okay, so why is this thing not working now? This thing is not working now. Jere toch, no. I don't like it. I don't like it. I'm a bit unhappy now with this question because it's giving us a runaround. And I don't appreciate it. I don't appreciate a runaround. But obviously we're going to have to use, I think we're going to have to use this at some point. It cannot be given for mahala. Okay guys, I'm feeling a bit beat by this question now because what I had in mind is not coming up. No, it's not coming up. It's not coming up. But in any case, if we focus on the initial ratio here, the initial ratio here is going to be basically 2y, and there's y in there. I'm trying to see if this is going to be of any help. No, it's not helping. Damn it, man. Yeah. Yanqhela. AH over HD. Sorry, ED. Why? Okay, I think it's gonna work, but I panicked. I think it's gonna work. I technically just panicked. There was no need to panic here. Right. So this implies that 2 times ED. Remember, AH is 2 times HE in general. So we're going to say 2 times HE plus HE. Therefore, ED, this is going to be basically 3 over 2 HE is done. Can you see that? That was a nasty question. Kind of forces your hand around. Yes. Give my heart. Let's go for the jugular then. AH is to ED. This is going to be the same. In fact, I will use the ratio because we need to work with something. So AH over ED is going to be 2 times HE divided by 3 over 2 HE. So now the HE takes the HE and we end up with AH divided by ED as, now this flips around, it becomes 4 over 3. We can say therefore in the manner that it was provided, AH is to ED should be equal to 4:3. Great. So as you can see, guys, a bit of thinking needs to kick in. Sometimes you change the plans. I'm lucky that I get these kinds of problems where you can see that you don't just always have it easy. Sometimes even an easy question to somebody else may not be so easy to you, you know. So this is just to highlight this, that sometimes you will struggle. Okay, sometimes you will struggle. As you can see, the 4 marks gave us the impression that this is a walk in the park. Maybe it is, but as you can see, it's not such an easy walk in the park. Okay, so essentially that's just how things worked out. Okay, that's how things worked out. That's how things worked out, and it did work out, but with some difficulty. Right, so if this is 4 marks buffet 2, I would give a mark here and give a mark there, and of course the answer in the manner that it's required, and one of the reasons. Okay, either this or the other one. So as you can see, the rest is your own problem. You just have to solve it. Okay, guys, sometimes it's a bumpy road. As you can see, I got to think a bit. Yeah. So 2.1.2. What was this question again? Yep, that was 2.1. Okay, let's say this is part of 2.1. Now this one is going to be easy. BE over CD. Let's see, where is BE? BE over CD. Now this one is a bit easier. This one is a bit easier because we've got this triangle ADC, and we're going to use that to our advantage. I'm going to say in triangle ACD, what do we see? Excuse me, so we're looking for BE. I know that BE over DC has to be equal to AB over AC. Right? It's the length of this smaller triangle divided by length that corresponds with it in the bigger triangle. Then it's going to be also equal to any side of the smaller triangle divided by any side that corresponds with it on the bigger triangle. So that's the idea here. So it uses the similar triangles, but in this case we are going to still say this is the prop theorem, and we know that EB is parallel to DC. Now this implies that BE over DC, right, is going to be equal to, now AB is nothing but 2x divided by AC, this is going to be 3x. Okay, so we just simply oopsie, this is gonna be like that. We now know that BE over DC should be 2/3. Easy. Okay, this one we just get the statement and reason and the final answer. This one is straightforward. So let's have a look at 2.2. Can you see, guys, for just a whole hour we just solved just 2 problems, literally. It's not so nice. Now it says if HE is 2 centimeters, so we know now that, okay, this is 2 centimeters. Calculate the value of AD times HE. Now we want AD times HE. So this is to suggest that we need to find the length of AD. It's just as simple as that. We just need to find the length of AD. And how will we find it? Now look at this. AD, if we look at it, we have some issues here. Do you realize that we did this here? So AD is basically ED plus HE plus AH. Again, we did this. So from those two, we can just combine everything to sort out this answer that we want. So now we are good because we don't have to suffer and do anything. We can just say AD multiplied by HE is going to be equal to AD. We know that this is going to be ED, which is 2/3 of HE. So this is 2 over 3. Okay, maybe let's make it a bit better. So this is 2/3 times HE, which is 2, plus HE, which is 2, plus 2 times 2, because we know that AH is 2 times HE. So this is very easy. Let's nicely close it. Come on, brackets and papel. Yeah, anyway, masiyeke kanjalo, and then we multiply this by 2. Oopsie. So we can say therefore AD times HE is equal to. Now we do the things that we are supposed to do, guys. So this is nothing but 2/3. Okay, let's do this. 2/3 of 2 plus 2 plus 2 into 2. And then we close. Then we close, and then we still multiply that thing by 2. Now your calculators can handle it. So this is 44 over 3. Now you can leave it here, or you can do it to 2 decimal places, which is going to be approximately 14,7. 6, 7. Of course, this is centimeters times centimeters, so this is going to be centimeters squared, isn't it? Because that was the product. Otherwise, folks, as you can see, there's no need to suffer here. Maybe I need the units to still prevail irrespective of how I present my answer. So obviously, guys, to calculate the length of 80 is what matters here and the correct answer. But remember, this answer is going to either be this correct format or you leave it there. It has to be correct and the unit of measurement. If it is forgotten, we are not happy. Okay, guys. So as you can see, folks, an hour can pass. Some questions like this can challenge you to the core, but do you see that our strategy, although it looked crazy, but essentially it made us to cruise in the last question, which would have been a tsunami had we not gone through it the way that we have. Sometimes a bit of planning is important in Euclidean geometry. So these kinds of questions are the kinds of a higher grade type where it's not so obvious. It's a blood, sweat, and tears and whatever. Okay, guys, let's move. How many marks would we have gotten here? Just 8 marks. Okay. And as I said, I'm trying to write this document as clean as possible so that you guys can download it in the description of this video. Any smaller spaces remaining can be used for some extra notes for those who are discerning, I guess. So the request by Katleho, is it Katleho? I think so. Said, I want a long video where you explain. So guys, this is going to be quite a long one. But I'll certainly not take longer than 3 hours. I'll try to leave it at 3 hours. Then if anything else remains, we will handle it separately. Okay, let's move. 3 says, in the figure below, AB is a tangent to the circle. So I always highlight what I'm given, guys, because not doing so will cause problems. Okay, AB is a tangent to the circle with center O, and we need to identify that center because there's a lot of information that will follow from there. Okay, right, now what do we know, guys? From just this piece of information, any line from center to tangent is going to be perpendicular to the tangent. So with Euclidean geometry, guys, you interpret information piece by piece. Don't read like you're reading some statement by some government official who means nothing to you. Every piece has a meaning here. Now we're told that AC is equal to AO. AC is equal to AO. Okay, so AC, we indicate, is going to be, perhaps let's just use colors because it's going to cause us a bit of a discomfort if we don't. Now AC is going to be equal to AO. Now me putting them in the same color is to try and highlight the fact that those are equal. Please remember that. It's not colors J for Mahala. I wanted to be able to indicate that these are equal. It's much nicer when you can, when I'm okay. But that's what I wanted to be able to do, because remember this line is continuing. Okay, so BA is parallel to CE. Okay, you can see this parallelity there. It's happening over there too. Okay, good. Now DC produced cuts the tangent at B. Obviously, this is telling us that DCB is a straight line. Once you hear that word, it basically means DCB is a straight line. So always understand the meaning of the statement given. It always will cause you pain if you don't put that into cognizance. Okay. I'm actually watching MotoGP practicing happening here. So I'm into bikes, folks. I own a 1000cc of a superbike, a Honda machine. That beast, man, it blesses me on that road. Dangerous as it is. I just love every inch of riding that bike. When I'm not feeling good, emotionally distraught sometimes, if I hop onto that thing just one leg over, you forget your problems. I promise you guys, you just enjoy every inch of the biking. It just keeps your mind so calm, but your brain so focused, you know. And again, precision matters if you're going to do biking. It's like doing mathematics. You just can't carelessly do it. You have to worry about a mistake. And you make sure that you keep your eyes, your feelings, your emotions in check, because you need to feel every movement. If it slides, you need to feel it and manage it. Because if you don't and you're preoccupied, you will make a mistake. You will be dead. It will be the statistics. Yes, I have fallen. The biggest fall was in 2016. Was it 2016 or 2017? 2016, yeah. That was my biggest fall. We were at the Pakisa racetrack in Oudendaalsras, Dane, just off Velkom. So there's that prestigious, racetrack. I don't know why the government decided to abandon that racetrack. If I had money, I would buy it and really bring it back to its former glory. MotoGP should be scraping their tires there. That track is perfect for MotoGP, even the landscape itself. But of course, it needs to be developed a bit. One day is one day. Anyway, guys, let's not go away from the reality. It's just that I see them on the TV and I'm watching as I'm doing this lesson. They're practicing so far. The race is going to be in the afternoon. For those who have DSTV, usually the sprint, is it the sprint? Yeah, they call it the sprint. The sprint race is going to be perhaps very late because they're in the US. So it's going to be somewhere around 8 at night, towards 9 at night. So if you're watching on DSTV, it's on the Motorsports channel. Okay. We used to see this on SABC3 when they used to come to South Africa. But yeah, you know this country, man. Good things that could provide more opportunities for people are not really looked after. They abandon them out of foolishness rather than reason. Anyway, let's not talk about these maggots. They just chew away everything that matters and leave garbage for all of us to share. There's nothing we can do about it. Those people are crooked. Okay, now folks, we need to think about our diagram before we start answering. We work on our diagram. Remember, during practice, this is what is expected of a student. We know that A4, right? Because I've got a tangent and a chord AC, I'm going to have a 10 chord situation happening there. So those angles are going to be equal. At the same time, I know that essentially this angle C2 is going to be equal to that angle D2. Again, what is the reason for this? These are angles in the same segment subtended by arc AE or chord AE in the circle. And there's more, folks. If this line is parallel to this line, now what does this mean? If I've discovered that I've got 90 degrees there, this is also suggesting that F4 must be 90 degrees. These are corresponding angles with those parallel lines. Now this further gives me more fire in the head that a line drawn from center perpendicular to chord will bisect the chord. You see the theorems in grade 11. So can you see, guys, a lot of damage has been caused. And of course, again, the 10 chord theorem would still come and say A1 is equal to D2 or C2, depending on which chord we are looking at. In fact, the chord is still EA, but depending on the angle that it subtends. So can you see the diagram now looks a bit nice because we have some things that we can relate to each other. Okay, now let's get to business. It says show that C2 is equal to D1. C2, this one, is equal to D1. Njani njalo? Hey, oh yeah, there's a secret to this. Yikes. Do you realize that this very same C2 is actually equal to that angle A4. These are alternate angles with these parallel lines. So as a result, my lord, it really works. Can you see? If you've done your job, you quickly see the links. If you haven't, you will start to sweat. Okay, now we can see that this is easy. All I know is that C2 is equal to A4. I'm going to use that property. C2. Now when you're referring to these angles, guys, it's a capital letter C. Spare that my writing is bad. C2 is equal to A4. Now with these kinds of situations, we expect a cap on the big letter. Okay, right. So this is the case, and this is the reason. These are alternate angles with essentially, is it AB, parallel to EC. How we name it doesn't really matter. So that's the first reason. We've got a situation that says, but, oopsie, what are you saying, sir? We know that A4 is equal to D1. Why? 10 chord theorem. The angle between the tangent and the chord AC is going to be equal to the angle subtended by that chord at circumference. So this is the 10 chord theorem. Nice and easy. Now we can see that essentially the link is A4. So we can make a conclusion that indeed C2 is equal to angle D1. Okay, that's it. You can say each is equal to A4, but it's quite obvious. But remember, in maths, we always prefer a complete reasoning. So each links nicely to A4. So if C2 is equal to A4 and D1 is equal to A4, then it means C2 must be equal to D1. 3.2. We now need to prove that triangle ACF. Where is it? So there is triangle ACF, nice and yellow. Or is it gold? Golden, whatever. And then ADC, vase ADC. ADC is, okay, we can make this one green. We can just complete it. Although we know something about it, when I'm saying papela, man, scam papela, man, ubatla unketsa roboto, wena man, na ke roboto. All right, so let's have a look at that. Are those triangles similar? Hey, it sounds right. ACI, man, where is ACF? Near, man. Near. So this is the triangle. I was wondering what's happening now. It's not making any sense. So what's happening here? We can already see this angle C2 is equal to D1. Nice and easy. They linked up to what? To that A4. It's already proven above. That's the first angle. But the second angle, we're going to have to use this F1, because if F4 is 90 degrees from corresponding angles, we might actually use co-interior angles instead. All right, so that we can prove that F1 is 90 degrees. If this is 90 degrees, do you see that this angle over here too is going to be 90 degrees? Why? C1 plus C2 is 90. This is the angle in the same circle, because AOD is a diameter, so that's the angle in the semicircle. So if we've proven two angles to be equal, the remaining angles are going to be equal as well. So all we need is just two sets. Okay, now let's go for it. In triangle ACF and triangle ADC, what do we see? Well, we're going to say, first and foremost, we've proven that angle. Now ACF has C2, so we know that C2 is equal to D1. Now at this point we can just say proved above. Okay, sometimes you may even want to be specific and say in 3.1. Easy. There's no harm in saying that. We can say here also, we know that in the triangle ACF, we know that angle F1 plus angle essentially BAF or FAB, let's just say FAB, this must give us 180 degrees. Why? These are the co-interior angles. We know that essentially AB is parallel to EC. Right. So this implies that F1 plus FAB, what do we know? This is 90 degrees. Equals 180 degrees. Oh, this question is becoming out of my... What is that? Why do we know FAB is 90 degrees? It's the tan red, right? Tangent perpendicular to radius. So this part is just to explain the 90 degrees. I don't want to go to town here, listing a lot of things. So we can see from here that F1 is equal to 90 degrees. Please, guys, show these things. Yes, it's for 3 marks. You may get the edge to just hoy the thing. No, you can't. Show us. Now we can say here, likewise, okay, it's not exactly, but it's similar. So we can say likewise, we know that essentially ACD is equal to 90 degrees. This is the angle in a semicircle, right? Because that's the angle subtended by the diameter AD. Now we can make a conclusion that therefore angle F1 is essentially equal to angle ACD, right? Now we know that each equals 90 degrees. That reason is weak. You didn't need to showcase it. Now, folks, once we've proven two sets to be equal, what can we say? We can easily say, therefore, triangle ACF is similar to triangle ADC. The reason is angle. Even if we didn't check the third, it's automatically going to fall into place. So don't sweat. Some things are nice to do, but they're not necessary, okay? But for those who like to show everything, they can tell us. They can tell us. Now, folks, this is very important to essentially do, right? So for me is, there's a lot, guys. There is a lot, I'm telling you. Anyway, this last one with a reason, maybe not. So essentially proving that this is 90 degrees, I think it's mark worthy. And to prove that F1 is 90 degrees, however we got to it, is best. And this is how I would give the 3 marks. Although this question could be given more marks, because it's not as simple as the examiners are making it to look. So let's look at 3.2 and finish this question. It says now we need to prove that AD is 4 times AF. Okay, so what is AD? This is the diameter. And we know that the diameter is 2 times the radius, which is, I'm sure you remember, what was, ebana, irauring bianong twin. Irauring. I see it. The diameter is 2 times the radius, which is AO. Now this is to suggest that AF must be half, or we can say 2 times AF must be equal to AO, so that when we double this radius and we're essentially doubling this, it becomes 4. So we can see this is all related to that radius. So we need to use AO as a way to go forward. But what we know is that AC is equal to AO. That statement that we were given over there. It's going to come to our rescue, but we're going to use also the proportionality of the sides of the triangles we just proved similar. Because once we prove similarity, we can use proportionality of the sides. Now let's have a look. We want AD to be a part of this. Now AD is part of the big triangle. So we can start then say, well, AD over. Now I don't do this thing, guys, of you listing everything, all 3 of the sides in the same proportion. I don't have the time for that. You can do it. It's not a problem if that's how you understand it. But here's how I understand this business. If I choose any side on the 2 triangles that are similar, I know that AD is opposite the right angle. Now I'm going to say this right angle is equal to which angle in the other triangle? It's F1. Now what is the side opposite that? Is AC. So I'm going to put AC here. Remember, with similarity, the ratio is made up of the sides that are opposite the equal angles in the triangles. So I hope this is clear. So the ratio is always made up of sides that are opposite the equal angles in the 2 triangles that are similar. I hope this is not Greek. Now this is equal to, I'm going to choose any other side that I know in the other triangle. Now I know that AF should be a part of this, so I'm going to put AF. Okay, I chose AD. Now I'm going to choose a side that will correspond with AF, because I want AF to come up. So I chose AD. AD brought me AC, which is fine. I'm good with that because AC gives me the AO. initially that was given. Now for me to produce this side, I'm going to choose AC in the big triangle. Remember, this AC is also part of the big triangle. So I'm going to say AC over. Now if I look at AC, AC is opposite this angle, D1. But D1 is equal to C2 in that triangle, and the side opposite that is AF. So that's what I want. Right, what are we going to say here? These are proportional sides of similar triangles in 3.2. Sometimes try to be very specific, guys. I know the reasons are acceptable as cryptic as you sometimes see them on the memos, and that's bad practice because the memo should not be complacent at any level. It should be more explicit than ever, because if these memos are to be made available to students, then they might as well be very good. But at the same time, teachers have the responsibility to explain, because the memos are not meant for students anyway. In general, they are meant for those who mark, and people who mark is people who know the subject. In fact, it should be experts in the subject. It should not be amateurs, because they will make mistakes due to their assumptions. Anyway, guys, I may sound arrogant in this regard, but that's just the way it should be, so that we don't have issues. Anyway, let's get to business, guys. We've got a nice issue there. We know that, well, AD is doing AD things, isn't it? So if we cross multiply here, I know it sounds counter what, it's not what. Remember that AD times AF is going to be AC squared, right? Don't worry, we're moving nicely. AD times AF equals, what did we say AC was equal to? AC was equal to AO. So this means this is AO squared, right? So that's what we wanted to do. Nice. But now I have a bit of a situation now coming up. It looks like these 4 marks are going to have to come from some silliness that's going to come up, because now AF in relation to Waits. I am not happy. Okay, but I think we're gonna try and do something about it. AO and AD are related, isn't it? Yeah, they are. Okay, we're gonna try and get this thing going. I think it's gonna work, although perhaps the way I started it looks a bit scary. It's not a big deal. We still have AD here times AF equals, what is AO? In terms of AD, AO is half of AD, isn't it? Yes, AO is half of AD because that's the radius. So we're going to write here half AD all squared. Mathematics is going to do mathematical things to you guys. Now we sort this out. Square the numerator is going to be AD squared divided by square the denominator. Nice and easy. Now what we need to do, guys, is cross multiply again. This is all over 1, isn't it? Yeah. So when we do this, we're going to get essentially 4 AF times AD is equal to AD squared. Now we divide by AD. Remember in maths, guys, we make it happen no matter how jiggy it is taking us. This one takes the square. And do you see? Therefore, we can see that AD is going to be times 4AF. It's done. It's finished. It's clear. So that's the thing, guys. That's the thing. So we know that it was given that AO and AC are the same. That's why I'm replacing AC with AO. But I also know that AO is the radius. So it is always half the diameter. I missed an opportunity to provide some reasons along the way, but some things are obvious, guys. You don't have to struggle trying to explain them. Now let's get the business. First of all, that was important. Statement and reason. And then we do the things when we substitute this, very important. And then we substitute this, very important. And then, of course, I guess for the troubles, we can just say an extra mark for the troubles. Because the answer was already made up. We just had to show how it comes about. Anyway, guys, this would be the 10 marks of this question. And you can see it's not so easy sometimes. Although everything is in front of you, it looks scary, so you take your time, play your cards very well. And this already tells us that AF is a quarter of AD, isn't it? That's what it is. It's a quarter of AD. Right. Okay, folks, do you want to take more questions? Well, I have done this question in the channel. So if you want to know about this question, I have already done it in the channel, so I'm going to skip it. There's a nice clear video on this question. This one is done. So please look it up. If you want, I'm going to show you the video at the end of this video. I don't find any inclination to showcase how things are done here. I would be wasting time. So we're going to jump to this other question. I don't know what this is called because they are all under 4. But I think it's 5 here. Let's do 5. I don't want us to waste time, honestly speaking. Even the others, I suspect I may have done them in some other videos, but perhaps they may be too far for you to find. But yeah, let's not waste time. Now we're told in the diagram alongside 2 concentric circles. What does that statement mean? They have a common center. Concentricity means they have the same center, M. Right, with the center M and with the radius 5 centimeters. So obviously this one to there is going to be 5 centimeters. And 8 centimeters, this means that one to there is going to be the 8,5 centimeters are given. All right, and then PQRS is a chord. Okay, a chord basically means it's a straight line. There's not a lot that we can read from there. Of the larger circle, cutting the smaller circle at Q and R. Okay, now we can see that chord. And then MYS is a straight line. Okay, we are happy that this is given because it may not necessarily be a straight line. So we need to know with y on the smaller circle, then QR is 6 centimeters. Okay, so QR is 6 centimeters. Hayibo. Ayisafuni wenza yaniphanyazela manginganiqheli. Ingakulengi ngiqhela. So that's 6 centimeters. And then we need to calculate with the reasons the length of PS. Oopsie. So our job is to find out. Remember, guys, I'm not talking about the arches here. I'm just trying to highlight this without tampering with those lines. The arch is somewhat giving us an indication of the length of the line itself. Because an arch in a circle sometimes behaves or gives us things that are similar, like an angle at circumference by the same arc or chord is the same, isn't it? Yeah, though. And as you can see, so sometimes with these diagrams, guys, don't be afraid to do a construction. As you saw in the above question, we've had to do some construction. So let's see what is necessary here. Well, this means we need to know this one. And we need to know that one. But saying that these are concentric circles, it means these distances are going to be equal. Right? They have to. If this is x, that should be x. Because the distance between these two circles at any two consecutive points, or should we say at points that are mirror images of each other, they will always be the same, because that's exactly the story about the concentric circles. So if you don't know this, that means you didn't really learn maths at all. Concentric circles are studied where? I started to hear about them in standard 7, grade 9. So yeah, so probably you've heard about it, I'm not too sure. Okay, guys, now we're moving slowly. As you can see, let me see how many questions still remain. I want us to really take down some nice questions quickly, but yeah, we will try, boys and girls, to do as many. Maybe let's stop at question 11. I'm going to try to move a bit faster at some point, but I just need to get your attention to think constructively. Now, how will we know what that distance R is? Now we need to know a property that a line drawn from center perpendicular to a chord. Now we're talking about this portion. Will bisect the chord. So this means QT must be equal to TR. If this is 6 centimeters, this is going to be 3 centimeters, and that is 3 centimeters. So you work on these diagrams, guys. You keep your eyes opened. If your eyes are not opened, you are going to die. Okay? You are going to die. I promise you. Now, as you can see, this still doesn't really help us much, because how will we know what this is? But if we have 1x, we already know that that is also done. So it looks like as we stand, we ain't moving in the right direction. But I've got a plan that can work. But it's either we do simultaneous equations or we do a construction. If I decide to construct this, what does it help me with? Any construction, guys, must be dashed to show that it was not there. But if I decide to do that, do you realize what it helps me with? I can now look at this triangle. I can look at this triangle. It's a right-angled triangle. If I look at that triangle, what do I see? I have this side. Guess what? That's the radius of the smaller circle. It's 5 centimeters. So I've got that side, the hypotenuse. I can work out this side, MT. Once I work out MT, I get into the big triangle, which is going to be this triangle. Hey, suka wena man. There's a naughty mosquito here trying to suck my blood. I don't have blood for those silly things, eh? I don't. In fact, I will kill it if it tries its luck on me. Right, folks, and now this means I can get into the bigger triangle. From the small, if I can get this side, then I can get into the bigger triangle. I will find this side. Once I find this side, I just double it and add the 6, then I've got PS. Okay, so it depends on how you want to plan it. Sometimes a construction may be needed, sometimes it's not. If I chose not to do this, I know that literally I will have congruent triangles. If I decided to perhaps go all the way, take it from here into that and back, right? If I did that, that would be another way. Then I could then use MT as a surrogate to link the equation so that I've got X in each, and then I win. So there's many ways of killing a cat, but as you can see, guys, you don't just jump in. Remember, practicing is something you do when you have time. You don't do practicing when you are rushing it. It's not going to work in your favor. In the exam, you will see, guys, you may be slow during practice, but I can tell you in the exam, you'll be able to see what you need in an instant if you practice very well. But of course, at some point, you will have to speed up, I suppose. Okay, we can start. And how are we going to start? I'm going to say let RS be equal to X. That is what I can do. I need to communicate what I'm doing because there was no X in there. But the other thing that I want to say is that join or construct MR. That means I'm going to use that such that, okay, you see, I've spoken to my examiner and I've already done those things also, and they can see what I'm talking about. Now, excuse me, I want to use the small triangle. I will say in triangle MRT. That's why I did this. MRT, first of all, I need to define the side. I know that TR is going to be equal to the half of QR. Now, what do we know? We know that the line from center perpendicular to chord bisects the chord, okay? But sometimes you may not need the last part. This part is not necessary. If you just say line from center perpendicular to chord, we know that it bisects that chord. So if the chord QR in the smaller circle is bisected at T, it means it's going to be like that. So we can say this implies that TR is going to be equal to a half. QR was 6. Don't rush, guys. Take your time. Be clear. This is 3 centimeters. Because I wrote it down, but it doesn't mean the examiner, or in fact, the person who's marking understands where you got it. So you've got to bring it alive. Now let's see what is the stories here. Now we want to get to Pythagoras theorem. So we can say here also, we know, guys, that mr squared is going to be tr squared plus mt squared. We knew that we needed mt. How do we know this? This is from Pythagoras. It's a right-angled triangle. Right, mr, we know that it's the radius of the smaller circle. So this is 5 squared equals tr, this is 3 squared plus mt squared. So this implies that mt is going to be the square root of 5 squared minus 3 squared. Therefore, mt is going to be, this is 25 minus 9, that's 16. Square root of 16 is 4 centimeters. So now mt is 4 centimeters. Okay, now we're getting somewhere. Now, what are we looking for, guys? We definitely want to end up going into the big triangle. We can say here, however, in triangle MTS, whatever, what have we noted? We've noted that the same thing. In fact, I can even say likewise, because I'm going to be using Pythagoras, but I think sometimes, yeah, let's just say likewise. This time, I'm talking about the big triangle, but I'll show you how to do it in style. Likewise, we know that ms squared is equal to mt squared plus ts squared. This is Pythagoras in triangle MTS. Can you see? If I didn't say in triangle, because I don't like to say in triangle, but you can do it. But sometimes you need to finesse your work a bit and just show you are good. Now this implies, we know that ms is 8,5 squared equals mt, which has found it. So this is 4 squared plus ts squared. Now this implies that we get ts is equal to the square root of 8,5 squared minus 4 squared. This implies that ts is, let's get this one done. So this one gives us a nice answer. This is 15/2. And you know what that is. This is 7,5, isn't it? Yes. We can leave it like that. Now, here's the thing, guys. Who is ts? Ts is tr. So this is tr plus rs. This is 7,5, which is 15/2. Now we know tr. This is 3 plus rs equals 7,5. In fact, we said rs is x. Sometimes I could have left it like that. So we can see, guys, that our x is equal to, this is going to be 4,5. Therefore, we can easily say rs is 4,5 centimeters. Yeah, holla sepadi jwale, holla sepadi. Go jwetsitse. Now, folks, you can see we're writing a math essay in this question. 7 marks are going to run your net. Now, folks, we don't need to explain why rs is equal to pq. There is no reason. These are concentric circles. We can say it if we like. You know, we can say this also means PQ is also 4,5 centimeters. We know that RS is equal to PQ because of these being concentric circles. You know, sometimes you say what you want to say, because I don't want to waste time talking, but I need to provide a reason for what I'm going to do. Can you see, guys? Now we get to business. Then we know that PS is going to be basically 2 times 4,5 plus 6. Therefore, PS is, this is 18, isn't it? No, it's 4, 8, 9. So this is 9 plus 6. So this is 15 centimeters. Remember, don't forget the units. So this is 15. Holla sepadi bana beso. Kuzwetsitse ka. Ho tlo ba e nngwe ntho mona. Ha o sa tsebe dintho tsa hao, di tla o tseba he tsona, hobaneng di na le motlotlo wa ho tseba hore hantle wena re o sotha kae ha re o batla. Tshwanetse wena o tsebe tsona he pele di tsebe wena, hobane ha di ka tseba wena o no kgona ho emelana le tsona. Jwale he o tla ibona ha o sa bale dintho ka tsela. Guys, this thing is something that takes time to do, unfortunately. As you can see, we have done our job. By the way, this statement here, this statement right here, you could easily have introduced it here and say RS, let RS, in fact you can write here, therefore PQ is going to be also equal to S, and then you give that reason. You can still do that before you move on, but as long as everything is flowing, guys, why struggle? Okay, so we finished, guys. 7 marks. How do we score it? This statement and reasons, perfect. Okay, finding TR was key to this. Pythagoras, we love it, of course, but we don't care much about it. And we will care about the substitution and this one and this one. 1, 2, 3, 4, 5, 6. Yes. 7. Kugqityiwe watsho uYesu eCalvary. So okay, guys, we get 7 marks. We move on. Let's get to this one. I don't know how many questions we're gonna handle, because I'm feeling like, wow. But again, I need you to understand, so I have to be as elaborate as possible. I mean, guys, I don't have to finish all of these questions in one sitting. I can do some, but this is our target if we manage our time well. But if we don't, then we didn't. Okay, let me not talk. Let me get to business. Now, question 6 says, in the diagram alongside, O is the center, so always identify that. If this is the center, we know that this is the radius. This is the radius. This is the radius. Those lines are equal. You need to know it. Okay. Circle PBDC. If we were to connect those points, we would have a cyclic quad, but now all we have is what we call concyclic points. Concyclic points are points that lie on the same circumference. Now, if POD is a straight line, this is a diameter. So a diameter subtends a right angle in the semicircle. And as we can see, the parallelity of these lines are telling us that this is also 90 degrees, corresponding angles. And if a line drawn from center is perpendicular to the chord, it bisects the chord. a lot is coming up. Of course, I'm just looking at the diagram. I haven't read the whole statement. BOT is drawn. Once we say BOT, we are suggesting that this is a straight line. Okay, please guys, understand maths. You need to know. If it is not given that that is a straight line, you won't treat it as such. Okay, it's drawn on chord PC. Okay, with T on chord PC, sorry. And then we're told here that essentially PD and BT intersect. The moment we call it as a unit, it tells you again that this is a straight line. So, and BT, again, once we call it like that, we are suggesting that this is a unit. So this is a straight line. So no mathematical notations. We don't just write. There's a message behind everything. Okay, they intersect at O, which is the center. Then CD is parallel to TB. We already saw that and worked with it. Now we're told PD is 10 units. So if PD is 10 units, if that's the case, sorry, not 10 units, but 10x units, and OT is 3 units, so that is 3x. Okay, nice and easy. Okay, all right, okay, so what is the story now? Determine TB is to TO. TB, the big one, is to TO. Okay, this one is easy. Now, do you realize that our information about the radii is important? Now, if this is 10, what does this mean? This means this guy is going to be half of that. So it's going to be 5x, isn't it? Yes, because that is the radius. Now, this also tells us that if that's 5, this is 5. So 5 plus 3, that's 8. Now, you see what I mean. Okay, so let's get to 6.1. 6.1, we want TB. Okay, so we know that. Okay, all right, okay. Let's first start by saying why TB is what it is. I'm going to say TB. Do I want TB? No, I want OB. I can say, well, first and foremost, OB is going to be half of DP, right? This is the radius, is always equal to 2 times the diameter. Diameter, here we are. Is equal to 2 times the radius, isn't it? So that means the radius is going to be half of the diameter. Now, we want to go about this nicely, guys. Don't rush. I know the edge is too quick. Remember, certain things, you must just be easy as you do them. OB is part of TB. That's why we're using it. So this is 5x. That's what you want to show. Now, this becomes easy after that. Then we know that TB over TO is going to be TB. It's nothing but OB plus OT, all divided by OT. Well, so this implies that TB over TO is going to be OB, it's 5x plus 3x. Of course, I'm just trying to indulge you guys. There's no reason for me to go about it this way. I could easily jump for the jugular. But I want to get used to simplification in maths, because at times it takes all of that in. All right, so that's what we have. So folks, we know that x is going to divide x to 1. So we can say therefore TB over TO is basically 8 over 3. Now what are we going to say? We need to write it in the manner that it is proposed. TB is 2. TO is going to be equal to 8 is to 3. Please remember, a ratio can be written in any way as long as it is understood. Of course, this is just 2 marks, as you can see. I could easily just write it nicely and quick, but you would not understand what happened. So I'm trying to help you to know this is important, guys. The answer here is not important on its own. The answer is the final one. But I just had to show you the steps to get around business, because a math student who knows what they're trying to do, they could easily have just scooped it from here. Okay, and made it as short as possible. But it's not about trying to be, careless. You have to understand what you are doing so that as you summarize in the exams, because in the exams we expect you to showcase your skills of being a student at school, that you have learned how to do things the long way, yes, but sometimes you need to finesse it and summarize. Remember, you learn summarizing in English. It still happens in maths. You need to show that you are not really going through school because you are put in school. You have to show us, guys, that you are learning something in the process. Otherwise, we should fail you ruthlessly. And it doesn't matter if you don't understand why we are failing you. It's a matter of you realizing that you're not doing your work properly. And it's not about being good enough. Yes, we can say that, but sometimes that transmits the wrong message, because technically you are being not good enough, but that is a temporary state in any situation, even including us as people. I may not be good enough today, but that doesn't mean I'm not good enough forever. It depends on me. If I do something about it, I might even end up being more than good enough. You know that? Because every state like that depends on you at that particular moment and what you do about it thereafter. If you want that to be a permanent situation of you not being good enough, then it will become permanent. Okay, guys, let's go. I'm talking and I'm forgetting that time is not our friend. Now let's prove that BT, okay, BT is perpendicular to PC. We already did, but now we're going to use the theorem. You see, sometimes I don't get this. I really don't. But anyway, the perpendicularity is going to start there. And then we use parallel lines to say this is the case. So first of all, we're going to start and say, well, angle C, there's only one angle C, so we can say that is 90 degrees. Why? This is the angle in a semicircle. Actually, I'm capable of writing nicely. It's just that I suck at keeping up. I think my profession has destroyed my handwriting. Even my brain, to some extent, I can see it. I'm not the same. Right, we've got, not implies, we've got a story that says but. What, mister? We know that essentially OTP, one time bin, is equal to angle C, right? Why? These are the corresponding angles with CD parallel to TB. Oh, we see that. Therefore, OTP is also 90 degrees. Let the deductions come through nicely. If that's the case, we can now say indeed BT is perpendicular to CP or PC. Sometimes try to write it the way it is proposed. Okay guys, so this is not too difficult. Sometimes they say statement and reason here, you know, most, and then that. The rest is your own problem because the conclusion was already made. So some things you have to say, but not necessarily for marks, but for the sake of coherence. Remember, you cannot give us cryptic statements that are flying around and we don't know where they come from and where they are going. We need to see that in you there is thinking as a process, of course. All right, guys, now we're getting a suplexity, and yeah, suplex us. It says express the length of PC in terms of x. Okay, so how are we going to do that? You know. We're gonna do it. We're gonna do it, but how are we gonna do it? We need this friend. Hatamela mona wena mutleki wena. Batla o bua le wena man hanyane man. Ska tata man, tlo pheletsa man. Etsang jwalo wa bona, ska mpora. That's how we say, that's how we manipulate them girls, isn't it, boys? But don't do it, it's dangerous. So this means we need to get into that triangle, because that's the quickest way we can get ourselves moving here. Because trying to find this, but we can, it's either we use that, okay, technically I just realized, technically it's not the only way. Another student may just be like, no man, it's a sing wenyana shilo shakunanzeka nisidiba kahle nisidiba nse. I don't know what that means, but yes, if you look at that, the midpoint theorem, if that is 3, this means this is going to be double that, isn't it? Sigiza. We can use the big one because we know that the hypotenuse is 10. We will know that this is 6 from the midpoint theorem. Why? Because the parallel side to the other side is joining the midpoints of the opposite sides. Even if we didn't know that that was a midpoint, knowing that this is the midpoint already, this side, if this is parallel to this side, it's already by default going to cut the other side in half. So it's either you use that knowledge or you just do your things, guys. You just do your things. So let's squeeze it here, Buffet, to 6.3. But honestly, in the exam, you need to give a space so that there's no cluttering. So which one do you want to work with, guys? Which one? Choose a le. But if you like, you can use Pythagoras on the small one. There's nothing wrong with that. And you will just know that OP is the radius, so this is 5. And we know that this is 3. We calculate TP, and then CP is going to be double TP. Easy. But let's use the big one just to cut to the chase, you know. We know that, folks, in triangle CDP, what do we know? We know, folks, that CD is going to be equal to 2 times TO. This is the midpoint theorem. You don't need to explain further than that. It's obvious. It's obvious. Therefore, CD, this time I don't care about substitutions. I cut to the chase, guys. This is 6x. If I was Bovelepi, that's your own issue. Ne? We can say then, we know, folks, that dp squared is equal to cd squared plus cp squared. This is from Pythagoras. We've already explained why that angle is 90 degrees. We substitute, so this is 10 squared equals cd, this is 6 squared plus cp squared. Now I'm moving like like a madman. This is going to be 100 minus 36. 100 minus 36, let's see, 100 minus 36 ke 64. Ha ke nka square root sa answer ena ke kreya 8. Ho tjho hore CP wa rona o tlo ba 8x. Re qetile. Ha re sa batla ho bua hangata le haholo mona. Haeba ha o fumane, o ke be wa nthola. Se ke ile jwale. I've given you options, guys. You can use the small triangle and use the theorem that says if a line is drawn perpendicular to the chord, it bisects that chord. That's how you're gonna, use that. Maybe some of you want to see it. So the statement, guys, and the reason is a powerful thing. And this one is also powerful. Although we normally don't care about intermediate stuff, it is key. Now this one, yes. What can you say? This one, yes. No, not that one. Substitutions are not really a big deal. Final answer is the one. Okay, guys, 5 marks in the bag. Now, let's say you chose the smaller triangle. We're going to say in triangle TOP. Bad word, that one. Termination of what? You. I won't even say it. If you didn't get it, you're not going to get it. Right, in this triangle, we've already proven that that is 90 degrees. So we can just jump in and say, look, OP squared must 2 can be equal to TO squared plus TP squared. This one, we know that that's the radius. So this is 5 squared equals 3 squared plus TP squared. Now, folks, I'm not going to tell you how to manipulate this. I'm going to jump for the jugular. So this means TP is going to be 25 minus 9, that's 16. Square root of 16 is 4x. Now I'm moving. We're going to say but. Oh, not even but. Then. We know that CP is going to be equal to 2 times TP. Why? A line from center perpendicular to chord bisects that chord. We're not even going to explain that. This implies that CP is equal to, by the way, we were told PC. Try to say it the way it was asked, because there's a very good chance you're marked by someone who's going to get confused by your own concoctions, although it's the same thing. Now, this is good. Therefore, PC is equal to 8x. Remember, that was in terms of x. Aguyole yonje. Iyo injengoba injalo. Eqonda. Kamokgwa elengayona. Okay, area provide a reason. This is Pythagoras. Re a ke ntate Pythagoras. Jwale he ntate Pythagoras a rena taba le yena. Ntho re na le taba le yona ke TP ka mona. Wa bona ntho ena. Mohlomong re ka bua ka di substitutions hobane o no sa tsebe hore ho yane OP o tlo ngola eng mane. Re ka o fa he ka baka la yona. This one, statement sa teng le reason. Ai, di bohlokwa. O ka se di tlohele ngwana motho. Answer ya rona re e batla le yona. Hobane ke yona hantle ne re e batla mona. Bana bes ke yona ntho ena he re na le 10 marks. Wa bona re thabile ha re le jwalo. If you didn't catch that, we are happy when we are like this. Alright guys, you can see these questions, you just have to enjoy working through them. Sometimes it's not as nice as you wish. Let's leave this for some extra notes. So let's do question 7. Okay guys, so I hope Katleho, was it Katleho? I hope you're watching and that you're enjoying what you asked for. You said a long, nice video. of me explaining, so I'm trying my best. I hope my explanations will meet your standard. If not, please let me know so that I can improve. Of course, we're going to do this in a few videos because, I mean, it's a lot. In the diagram below, two circles intersect each other at A, there, and B, there. Okay? ED is a tangent. I want to highlight my tangent because the tangent things must be highlighted so that we can be able to do the things that tangents do. Okay, that's a tangent to the big circle essentially. Now folks, if we start with that, we know without any shadow of doubt that this angle is going to be equal to, now this is the tangent, chord is CD. It's going to be equal to that angle. Okay? So that's the 10 chord theorem. However strange it looks, that's what it is. That's what it is. But we know that that angle that we just looked at is vertically opposite this angle. From grade 8, vertically opposite angles. So this already tells us that this angle 2 can be equal to those others. Abana he jwale se re buile ntho tse ngata. Empa ke nnete he a se mashano. Re buile nnete fela. And hantle ntle re tseba hantle hore nnete yona ya sala. Nnete yona e etsang ya sala. Okay guys, we've said a lot, let's move. ED is a tangent to the circle ABCD. Okay, ABCD. You can see this is a cyclic chord. Right. Now you can already appreciate that we've got a cyclic chord. Please guys, always try to look at these things. You will see how far this is going to help you. All right, so let's see. What else is the story? DA, the Democratic Alliance, is a tangent itself to the circle AKB. AKB. Right. So that's the circle. So this is what I call a cyclic triangle. You know? So obviously, guys, if we just keep to this color, you will then appreciate that the angle between the tangent and the chord should be equal to the angle subtended by that chord at circumference. Right? And if we know that AF is a straight line, that C1 itself should be equal to A2 because that's the exterior angle of a cyclic chord. If at all we decide to say this is a straight line, I'm not too sure at the moment, but we'll find out. But if we make that assumption, remember sometimes you can already see ahead. Okay, so that's fine. And then we're told indeed that, we're told DBK is a straight line. DBK, okay, that is a straight line. Okay, not a problem. AK and DC are produced to meet at L. See that? And what was this? AK and DC. True, so this means we're indeed correct. It's a straight line. Once you hear that a side has been produced, it means it's a continuation of the same straight line. Now LCD and AE are produced again. This is to say these are straight lines to meet at F. So this is good. So nice and easy. We can even, extend this line because we have been told that that component is one and the same straight lane. Is it lane or line? Yes. Okay, we're also told that CD, this line, is equal to DF. Oopsie. So CD is equal to DF. Okay, that's fine. Now we are good. We are ready to see even more. But sometimes don't go too far Sometimes annotate the diagram just enough to see a few things, but don't take it too far. You will run into big problems. All right. Okay, all right. Now I want to know whether these things are telling us the thing. Okay, guys, I think this is fine, so we can start. 7.1 says we need to prove that LKBC. So this is this cyclic quad over here, LKBC. We need to prove that this is a cyclic quadrilateral. Do you see what I see? Yes. Do you see? We said that angle is equal to that exterior angle of a cyclic quad. This was already given. But this is equal to that 10 chord theorem. Do you see this one is equal to that one? So that becomes an exterior, but now it becomes the converse of the exterior angle of a cyclic quad. Oopsie, is done just like that. Can you see 5 marks, guys? In an instant, analyzing the diagram and learning a thing or two, you already are 5 marks rich. Now this becomes a piece of cake. So how do we want to do this? Well, we want to do it like this. We want to take this angle, which is the exterior, and link it to C1. But we're going to start here and say K2 is equal to A2. So we know that K2 is equal to A2. What was that? This was the 10 chord theorem. Right? That's the 10 chord theorem. Now, we have a story that says also, what do we know, guys? We know that A2 is nothing but equal to C1. What is that? This is the exterior angle of a cyclic quad. Sometimes I state the quadrilateral I'm talking about. The quadrilateral is ABCD, as it was given. Because there may be a lot of cyclic quads. So if you just say exterior angle of cyclic quad, I'm not sure which one you're talking about. And what if you're lying? So be exact, guys. Be precise. I should not ask a follow-up question. I should get it from what you said. And if I want a follow-up question, it must be because of interest, not because I don't understand. Now we already can link these two now, guys. We can say, therefore, we can already see that basically K2 is indeed equal to C1. We can say, therefore, we can now prove that this one, LKBC, is a cyclic quadrilateral. Reason, this is the converse of exterior angle of cyclic quad. Right. So remember, usually we need to know that it is a quadrilateral. I mean, it's a cyclic quad. Then we can say the exterior angle is equal to the opposite interior angle. But now we've proven the angles to be equal before we knew it's a cyclic quad. Hence we say it's the converse. Okay. Please be aware on how we phrase the reason, because but again, even if you phrase it otherwise, as long as you will capture what is needed, we will be happy. Can you see these 5 marks are not too bad? So this is suggesting Banabesu. This is statement, reason, final answer, especially the reason, because this is already a conclusion you should be able to make. So we're not going to reward you for that, but it's a means to an end. Okay, guys, easy 5 marks. As you can see, some questions look scary and they are not. It's just knowing the connections, but others may look easy. You see 3 marks, but it's quite a long walk, so don't be fooled. 7.2 says we need to prove that B2, where is that? B2. Wow, orange. Here is B2 mos. Okay, let's use another color that is quite visible. So we need to prove that B2 is equal to LAD. My lord, where is LAD? You see, sometimes a question like this may look too simple, but it's not that simple. Hey, yes, Pekkas, how are we gonna do it? Okay, let's first look at B2. Where is that B2? If I'm looking at B2 in relation to this yellow triangle, it's an exterior angle of this triangle, meaning it's going to be K2 plus A1. But what is this angle LAD? It's this angle, which is equal to that, plus that same angle. So indeed, ziyalingana. Yewena uzosibulalisa. Right, so let's start. We know that B2 is equal to K2 plus A1. This is the exterior angle of triangle. Please name it AKB or ABK. So that's easy. We want to say something also. We can say also, we know that this LAD guy is nothing but the sum of angle A2 plus angle A1. Okay, that's obvious. We don't need to explain anything. We can say, but we knew something from above. We knew that basically A2 is equal to, now you get it, is equal to K2. A2 is equal to K2. That was proved above. We now can make a conclusion that LAD, instead of A2, we write K2 plus A1. Now we can clearly see that, yes, indeed, B2 is equal to LAD, because, each of them is this value, A2 plus A1. At this point, you don't want to explain, but if you want, you can say each is equal to K2 plus A1. Did I say? This is what we want to say. You can say each is like that, but it's too obvious right now. We don't want to talk. We want to move. Right, so this statement and the reason is hut. Right? The substitution here is like stuff. And then we can make the conclusion. Of course, it's ridiculous the way I'm doing it. You could easily get 2 marks for a statement and reason here. Usually we can say 2 marks. And just proving, that LAD is like that. That is good. The conclusion was already suggested. It's not a must. I think this is the best way to mark it. So 7.3 says, we need to prove that DE is parallel to LA. Oh, guy, this DE is parallel to Los Angeles. This one. It's nice, this thing. It's nice, this thing. So let's check. How is this going to work? Do you see, if I already have proven that this, remember sometimes the information above is good. So I already proved that LAD is equal to B2, but you know what? B2 is actually equal to this angle. Why? 10 chord theorem. Remember the chord, remember the tangent, ED. This is the angle between the tangent and that chord AD, and that chord subtends B2. So that's the 10 chord. But now do you see this angle ends up equaling that angle? So those are alternate angles. So remember, alternate angles are only equal when the lines are parallel. So we've got a game plan now. So all we need to say is to say, okay, fine. We can start here and say this is equal to that 10 chord, but this we just proved is equal to that. That means these two are equal. Then we make our conclusion. So we're going to start and say D4 equals B2. This is the 10 chord theorem. At this point, we don't want to say too much. We know though that but B2, you proved it's equal to LAD. That you can say proved in 7.2 if you like, or you can just say proved above. Anyone can go and look for it. Sometimes make it hard for them. They must go and look, so that if what you are sending them to is wrong, if they're lazy, they're not going to look for it. They're going to give you the marks, and then you win, even though you lost. Sometimes be strategic, guys. You know, as the type of a student who, when they are wrong, I pretend I'm right. You know, we used to get the switch. We called it the switch. They used to give us punishment for getting an answer wrong. So you'd get a cane in your hand. So the teacher asked, it was about the thermometer. That was grade 7, standard 5. So we studied stuffs about the thermometer. So we knew that when it is hot, it expands, okay? And when it is cold, it contracts, okay? So I forgot the expand part. Now the teacher asked, what does the thermometer do when it's hot or when it's warm? I forgot the expand. You know what I did? My hand was up because I knew. He knows I can answer, and I was tired of getting a switch that day. The English class was already rough on us. Our principal, Mr. Baghetti, was a disaster. Yo, that man was a tsunami, I tell you. There was never going to be an escape from the cane. So I was tired of the cane. So when Mr. Mpomani came, Linda Mpomani was something else, but he was a good teacher though. But the cane was your friend with that man. So he asked the question, and I knew that guy, the lectures he used to give, they were not nice too. He was someone who could give it to you. So I was like, my hand up, and then he started eating his sheep. He chowed them. So I was hoping one of them is gonna save me, my group mate. You know, that was the first time they started this nonsense of, you know, putting us into groups. So I was in a group with a very smart girl, you know. I hope she's not gonna mind me mentioning her name. She was one from the village, a very brilliant one. She was always number one, that one. So I was hoping Unontobeko is going to save me. Unontobeko got the switch. I was like, now my only absolution is that day. So, but then there was another smart one, Samkelisiwe. Nayo Samkelisiwe was one of those tough ones. She was either number 2 or number 3 or something. I was always sandwiched between these girls anyway. So, you know, a bit of being a boy was always present. So I never really cared to really outsmart all of them. But when I could, when it comes to maths and science though, guys, I didn't have a size. I can say it now. They know it too. They beat me overall, but come to maths and science, I was a god, and I've always been. I'm sorry. It's either you take it or you don't, but I've always been a god of this subject. I was born for this, folks. I'm sure you guys can see it yourselves, even though you may not want to. Anyway, let's leave the nonsense, me blowing my own horn. But if I don't blow it, who's going to? Come on. Hi. So anyway, now Samkelisiwe and myself are left in the class now. Now the Tempomani doesn't know who to take down because he knows I know the answers. So he was like, this one, I need to get one of these two. I cannot have one saving the other. He would come to me and then I stand up, be like, no. Hey. And then he goes to some Samkelisu, and then Samkelisu stands up. He's like, no. You're going to save my jagalas there. And then he comes to me, and then he doesn't know who to go to, and then he ends up standing in between our desks, and then he doesn't know who to go to. And then, of course, out of being a man, he decided, okay, if the boy saves the girl, it's more appropriate. But yeah, and then when I stood up, I gave him the hand. He's like, what's You're like, hey, what's why not don't confuse man? Now he ended up never asking me questions. He would just chow his sheep, finish them, because he knows I'm a thought. Sometimes when I know I have an answer, but I want to save the group, I'll just pretend I don't have an answer, not raise my hand. He points at me fast and furious. I stand up, I shout the answer. It's like, when I global eye on. And now it's a humble one. So you see, guys, you need to enjoy school, man. Let the teachers, hate you nicely instead of hating you badly. Because I was hated nicely, man. Anyway, I'm giving you tips here to deal with those teachers at school. But I had the best, guys. Oh, I had the best. I would be lying if I say I had the worst. Of course, every now and then there would be one of those teachers I would rather. I wish I was never taught by this one. But hey, God doesn't give you flowers all the time. You're going to have to deal with the other stuff so that you learn. Remember, life is a process, guys. You learn everything. If you only learn good things, you're going to be tricked by some bad things in life, and then you're going to sink despite what you could have done. So you have to be resilient. Sometimes you're going to get a bad teacher, but you have to surpass that, because God is teaching you something through that person. That at times life is hard, unfairly so, but so what? And then you just have to deal with it. Position yourself in the winning position despite the situation. At the end of the day, as you become an adult, you're not going to be miserable and depressed and stressed and anxious. Even though things are going to happen to you, you will be able to take them on the chin. But those who always expect things to be perfect and to be good, to be to their satisfaction, when they become adults, they make the worst of adults, because as productive as they can be, if they get knocked by something, then they just dwindle. And it becomes a sad situation. And you can see a lot of them. They're starting to show. These are brilliant people. They're qualified. They're certainly worthy of those qualifications. But yeah, you can see sometimes when struggles hit, they cannot take it. As a result, they become a tsunami for themselves and for those around them, and to some extent, the country at large, and we should not have such. Anyway, guys, time is not on our side. We've done our job. 3 marks. I went. I talked too much. So now, guys, what we were trying to do, we were trying to link. Basically, we're trying to link LAD and D4. We can just say, therefore, D4 is equal to LAD, the lad. Hey, you lads, sit at my feet so that you can learn something. Now, if those two angles are equal, we can then make the conclusion that yes and yes, we understand that definitely DE must be parallel to LA. Los Angeles, isn't it? Have you ever been to the US? California? Los Angeles? Have you been to California? Hell no. If you want to know America, you gotta go there. You gotta get the real American things there. New York is gonna give you lies about America. California, Texas, yeah. Houston, is it Houston or is it Houston? You're gonna learn the things there. Now, guys, if this is the case, we know that alternate angles are equal. If alternate, not alternate, alternate angles are equal. Use as many symbols as you can. It's normal like this. Okay guys, so once you prove there's no converse here, maybe you can say converse of alternate angles if you like, but I've never seen how to reason around this. If I prove alternate angles are equal, obviously conversely the lines are parallel, I suppose. But we always treat these not as theorems but as axioms. Is it axioms? Yes. Or corollaries, you may think of it. I sometimes don't know the difference between the two. What's an axiom? An axiom is a true statement. But what? What about it? And a corollary. All I know is that a corollary is a true statement, but you cannot really provide a proof for it, although you know it is true. That's a corollary. This one, we can regard it as such. It's not necessarily an axiom. It's a corollary. It's a corollary. It's a corollary. Is it a corollary? It's not a corollary. It's a corollary. Corollary. Aibo. Corollary, man. Aye. And the English, the vernacular. Statement, reason. Then the reason for the answer. The link is just what it is. It's just what it is. All right, we are doing fine. We're doing fine. Now let's take our water, guys. 5 marks lento. Niyasiqhela. So sekalo. Niyapambana. Niyapambana. Chini bafundini. Nifuna uthini ngo? Kaloku incinci le nto la. Msebenzi efanele siwenza apha mncinci kakhulu. Senisenzele wona. I don't understand. Soze kodwa ibe 5 marks le. Basenithanda. Unless sometimes it happens that the examiners have thought about it the long route, maybe. But you know what, in life, guys, don't complicate your life. Take the shortest route to Jerusalem. Resultant distance. We don't want to go around these other things. Science teaches you that, look, if you want to go there, try to survive a few issues straight up. You're going to get there faster and with less energy than you would if you go all around and have to face all the troubles. I don't believe this is 5 marks, but let's just pretend this was for 5 marks. You would get the marks, okay? Because I would give you the mark here too and say, well, this is good. Although we got a mark above, but to bring it here is good, and then this is good. In fact, I would say maybe I would leave that and say 2 marks for getting here. And then final answer. I mean, you still get full marks, guys, even if you chose the wrong, the short route. In case there is a long route there, be that it. But be that as it may. Wow. I'm confused. Be that as it may. I'm like, wow. Can man abelungan kangen beve azanifani nibeve bethetha kanjalo never ilapha kuthi lento ukuthetha into ezingenangqondo. Anyway guys, umsebenzi ubana nendaba akekho. Right, okay folks, let's get to business. Last question. You know almost the ratios. So this is already telling you and I, we need to compare things. Now let's trace them. Now this is again a skill I want to impart to you guys. Don't panic when you see these things. You just trace it and say, look, where is CD? I just want to know. CD is here. Is that length? Okay, what do I know about CD? CD is the same as DF. So this means I can interchange these two. I can either use DF and CD because there's a very good chance CD is just being used indirectly, because that statement was already trying to give us something that there's going to be a catch along the way. Okay, so that's sorted. Next one, FA. Hadamelamona. Diamond, where is FA? FA. There's FA. Oopsie. Okay. FA. Hey, atufuna siqhela. But nguwe. All right. Okay. But now if we look at this, we can already see FA is part of this triangle. So we can already see something developing, right? Because FA is the side of this triangle, and we already know that CD being equal to DF is literally here. We are talking about this dude indirectly. Okay. Now let's trace it again. See guys, you will always know where these dudes are. FE FE is now this portion. Now matata jwale. Okay, all right, okay. So FE sekuvele ezinye izinto ke ngoku, like okay, umbani ke ngoku wena, unumber bani? FL. FL. Okay, maske sijonge. FL uphi ke ngoku yena? Nankiya. Okay. So sikujongile, siyakubona, sikujonge kancinci, siyayibona le nto no man. Ayinanto yakwenza nale triangle ke ngoku. Qha inento yokwenza nale parallelity siyiprovela. Yes. You know most the proportionality theorem. So this means we are looking at the big triangle FLA with this side drawn parallel to the rest of the triangle. I'm sure you can see it. Let me highlight it for you guys to see. I'm going to highlight it with the blue color. So do you see this blue triangle? This blue triangle. Do you see we just proved that DE is parallel to LA? And in this big triangle, we can see that this side can be replaced by that. Over that should be the same as this side over this. That's proportionality theorem. Is the proportionality theorem? Yeah. So we can just say in triangle AFL. Sesibonile, sesiyazi ukuthi FA, I mean we can start with DF over. Now DF over the whole side LA. Kiona must is it FL, sorry, FL. Must be equal to EF or FE over now the whole side of FA. So this is the proportionality theorem. We must state that DE has been proven parallel to Los Angeles. Okay, so can you see guys, this looked too difficult, but it's actually not as difficult. But seeing 4 marks, I get the feeling that we needed to prove some similarity, but who cares? You can if you want, but there's no need. It means the examiner thought of the similarity, but proportionality just tells us. We will say here, but we know that DF is equal to CD. So this implies that instead of DF, we're going to put CD over FL. This must be equal to FE over FA. Now I'd like to continue here. So when we cross multiply, we make our conclusion that indeed CD times FA is equal to FE times FL. Proven. Is nice, is good. Again, you will get full marks because they will say statement and reason, substitution, and the final answer. Yes, it was given, but you showed us how we came about it. You get 4 marks, unless there's a mistake, but for me, this is 3 marks. But there's nothing wrong because someone thought maybe you needed to prove some similarity. At this point, I am not interested. So this is 10 plus 7. So this is nice, 17 marks. Now this is typical of an exam question that you would get as perhaps the last one in Euclidean geometry. Okay guys, you can see my annotations of my sketch are nice and sweet, clean and easy to follow. And you can see even if you're not using something that you can rub, because you don't need to rub and then write and then rub and then write. Remember, some of the annotations are important to move along with. So annotate such that you don't forget what you've written. Of course, the last or the final annotation, as you could see, you can overlay on the others, because at the end of the day, this is to help you give to the marker the answers. The marker has to understand and follow you. But if you also annotate your diagram nice and clean like this, and you try to make it your best effort to not make it a mess. You don't want to write and rub and scribble. Make it nice and clean. So you've been taught, guys. You've been taught. And you can lie and say you don't know this, but it's only because you want to close your head into this. But you have been shown. You have been shown. So question 7 was a bit nice. Let's take question 8. All right, so you can see that you get combinations of things. Similarity, here we didn't really need to, but we could have if we wanted. Okay, let's get to question 8. Question 8 says, in the diagram alongside, ABCD is a cyclic quad, and we can see, guys, this quadrilateral is nice and complete, and it has all the 4 vertices at circumference. I don't need to highlight it, it's obvious. Right. E is the point on the diagonal AC. So there is E, such that D1, this is the angle, is equal to D3. Okay, this is given. We are not finding it out. We are being told. Okay, that's fine. And then, of course, now we can go to town with the diagram and say, okay, what else do we know, folks? From here, we just need a few angles that are equal. If you look at D1, D1 is subtended by arc AB or chord AB, but that same chord subtends C4. So those are angles in the same segment subtended by arc AB or chord AB. Okay, and we also know that this dude, following the same thinking, is going to be equal to A1. Again, those are angles in the same segment subtended by chord CD or arc CD. Now, obviously, guys, when the diagram gets busy, you stop, okay? You don't want to go too far to avoid unnecessary strain. You leave that. But of course, I can do the last one and say this again over the same reason. Do what I want. A2 is going to be equal to D3 and 2. Again, those are the angles in the same segment subtended by chord BC or arc BC. At this point, we want to stop and get to business. Remember, don't go to town too much. As you can see, just a reasonable analysis will take you far. Now we need to prove, of course, this one starts with the ratios. We need to prove that EC times BD. Now we need to trace these. EC, where is it? EC is over here. Okay. But I don't want my numbers to be covered. So when you're inside a diagram, try to use, something that can see through so that the lines are not obliterated. And then we look at BD. Where is BD? BD is over here. Okay, can you see a see-through? We still see that angle, that numbering, so you choose something like a marker for inside the diagram so that your annotations are still visible but clean. Now we want AB. Now AB is here. This one you can choose any color on the outside, but since we chose to use this, we might as well, but I think we are safe with AB to just do this. I think we are safe to do this. On the outside we can use this, and then CD. Okay, so what are we noticing, guys? What are we noticing? Well, what we can notice is that this AB and CD are the sides of triangle ABD versus BD. We said what? AB and BD are sides of this triangle versus CD and EC. They are sides of that small triangle. So this means we're working with these two triangles. So this means we're working with those two triangles. So we are comparing these two. So what do we know? We were given that angle is equal to that. So we already have that in the bag. But now we need one more connection. Now we can already appreciate that. Okay, all right, okay. What color can we use? Let's use this one. We can already see, guys, that this angle is actually equal to that angle. Can you see? That's all we needed. So those are angles in the same segment subtended by chord AD or arc AD. So if we prove two angles to be equal, what is left? They are similar because we just need two sets. Once we have two sets, the third angle will automatically fall into place. So this means this uses similarity. And can you see, it cannot be 3 marks, guys, because there's a lot of work to be done here. But hey, it is what it is. So examiners can hide the fact that you've got a lot of work to do, but you just don't see it. So we will start by saying in triangle, we can start with the small one, say ECD or CED, and triangle ABD. Can you see we used the sides in the ratio to identify these structures? First and foremost, we know that in CED we've got angle D1. This is equal to angle D3 in the big one. No, the other way around. D3 is equal to D1. This was given. That's the first thing. Second thing, we know that essentially C1 is going to be equal to B1. These are angles in same segment. Sometimes it stops there, but sometimes I prefer to say subtended by which arc, AD or a chord AD. But it's understandable. So if we've got two sets, guys, there's no need to say more. We can just simply say triangle CED is indeed similar to triangle ABD. The reason it's angle. So if you've proved two, the third angle falls into place. You don't need to write it down. So from here, what do we know? We know that this means we use the sides now. We can say EC over. Again, I don't fancy this writing the entire ratio and then you play around it. It doesn't matter, guys. That's why even naming the triangles, I don't care how I name them. Yes. The naming sometimes can have a message of saying which sides are in the same proportion. But remember, what if the examiner decides, as you can see, we trick students however we choose. What if they decide to write the triangle name however they choose, because there's nothing that says you have to write it such that the corresponding sides of similar triangles are in the same proportion. I can write it however I choose. It's still the same triangle. Now this means you need to be careful. Okay, now I look at EC. That's how I do this. I look at EC. EC is the side of the small triangle. It is opposite the angle D3. But angle D3 is equal to D1 in the blue triangle, and the side opposite that is AB. So it's always the sides, guys, that are opposite the equal angles in the two triangles, which make up a proportion. Now, I know that I'm just using this structure to construct this ratio. I need CD now, because CD is part of this. So I'm going to say CD over. Then CD is this side, which is opposite E2, but E2 is going to be equal to A1 and A2. Although I didn't mention it, but it's the third angle. So the side opposite that angle is BD. Okay, now I cross multiply. And of course, you need to provide a reason here. Some people just write similar triangles. Sometimes I say these are the proportional sides of similar triangles. From here we can see that EC times BD is going to be CD times AB, or perhaps they started with AB. So always make it a point that the answer is as proposed. Try not to write it your own way. So as you can see, guys, this one was given. We're not going to get a mark, but this statement and reason, we probably want to give it a mark. This, we want to give it a mark. That gets a mark. This was already concluded. We just needed to show. All right, so you can see, guys, yes, it does fit 3 marks, provided you don't give yourself unnecessary extra work. Guys, 3 hours has completed. Now I need to move a bit faster so that we can finish the amount of work that I think we should. Now the next one is this one. Okay, I'm sure you can already see that it's 5 marks. We're gonna need a new set of similarities, definitely. So now let's trace which sides are these. We've got AE. Where's AE? AE is here. Right, that's AE. And then I've got BD. BD is that red side that I already have. Okay, so we know BD from above. And then I've got BC. Now BC is on the outside. I can show it nicely. I can even use this color. So there is BC. Now BC and AD, where is AD? Is that side. Okay, so AD is there. Okay, I know the diagram looks busy with all these curvy lines. What is nice, they don't destroy anything inside the diagram. If you're gonna do this, try to use your marker so that it doesn't shade this away. Okay, now folks, what do we see? Who are we comparing to who? That's the main thing. Well, we've got AE and then we've got AD. So it looks like we're comparing this triangle, right? That triangle. And with who are we comparing it? Okay, this one we are comparing it with wait, scattered. Let's see again. We've got AE. So AE is this side, so it's not complete. So if it is not complete, it belongs to this triangle. So definitely it's this triangle. Let's shade it nicely. So definitely this looks like that AE and AD belong in this triangle. Now we are comparing it with which triangle? We see BD, so that side. So this is this whole side. And then BD and BC. So it means we are comparing this triangle and this other triangle. So at this point, we're going to outline it blue. All right, guys, so I decided that I'm going to make it green. So you can see we're comparing this shaded triangle and the green outlined big triangle. Okay. Remember, the colors are to aid you as a student, but at the same time, you also want to leave it clean enough for the other person to see what you're doing. So what do you notice, guys? We already said B2 is equal to A1. Those are angles in the same segment subtended by chord CD or arc CD. So they have something in common. Now, what else do they have in common? If you look at this angle C, C1 plus C2, what do you notice? We will notice that this involves angle E plus this angle, okay? Right? Angle E plus that angle. Now, what else can I say? If I look at this whole angle, let's make it, what color can we make it? As a whole, we can make it nice and green. We can say, well, this angle as a whole if you look at it, you can see that it's this color, whatever this color is, plus the red one. But do you see that this angle is going to be the same as that angle? Why? Because it is the exterior angle of the initial triangle, this one. So this one becomes the exterior because it's going to be that angle, which is that small one, plus this angle, which is still that same angle. So once you prove that those two are equal, then we have proven our similarity. Then we can use the proportionality of the sides. So as you can see, guys, oopsie, kematata. Now the questions are becoming harder. So we know that we're dealing with triangle AED or ADE and triangle CBD. Those are two geography. They will talk of the central business district. Okay, let's start. We know that in AED, this is A1, is equal to, in CBD is going to be B2. These are angles in the same segment. Okay, and then 2, now this one's going to use some crazy stuff. We know that we're going to have to say this one's indirect. We can say A also. We know that if we start with E1, E1 is going to be equal to D3 plus C1. This is the exterior angle of triangle CED. Okay, so can you see we are using some technique now to get around business. The next thing we want to say is that likewise, we can see that, oh, maybe let's not rush. Let's not rush. We can say what D3 is equal to that E2. But we never spoke about our E2, so we need to state that. We can say here, however, what can I say? However, what do we know? We know that essentially, guys, E2 is equal to D3. These are angles in the same segment, subtended by chord AB or arc AB. So what do we make out of this? We know that now E1 is going to be, instead of putting D3, we're going to put E2 plus C1. So that was the tricky part. Okay, you can see this one becomes a bit naughty. So that's what we wanted to get to. We can say likewise here. We can see that essentially angle CBD is nothing but E2 plus C1. That one is given. It's straightforward. You can see that. You can say given, or you can just leave it and say C diagram. It's there to see. Now what can we conclude, guys? We can conclude that therefore this E1 is equal to CBD. That was the essence of it all, because all we wanted to prove was that they are each equal to the same angles added together. So that's what we wanted to arrive at. Now from here we make the conclusion that therefore triangle AED is similar to triangle CBD. We proved two sets. That's good enough for similarity. You don't need the third angle per se. Now we're going to use the proportionality of the sides. So this also concludes that. Now we want to use this side strategically. AE over. Now we go on through the same process. AE is opposite which angle? This angle, D1 plus D2. We know that automatically this would be equal to this angle for the other one. Again, you can already see what it includes. This piece and that. Whereas that also is that piece which is equal to that, and then that small piece. So it is indeed equal. So we know that AE is equal to D1 and D2. But D1 and D2 is the same as D2 and D3. And the side opposite it is BC. So we're going to put BC there. This is equal to. Now we're going to construct this using this. BC is already there. So we're going to choose AD over. Now AD is the side opposite that angle E1. But we said angle E1 is equal to C1 and C2. And the side opposite that is BD. Now I'd like to complete my answer here, therefore. So if we cross multiply here, what do we get? We get AE times BD becomes BC times AD. Done. Usually 5 marks when you have ratios like that, you know similarity is hidden somewhere and you're going to have to bring it home. So how do we get the 5 marks? We will say statement and reason. It's important. And I think this statement and reason is important, but now this reason, we've already mentioned it. We're not going to get a mark necessarily, but that is good enough. Okay. Excuse me, guys. So this is the 1, 4. And then here, I forgot to mention the reason, so we can just say similar triangles. Please don't forget that, because this is mark worthy. To come up with that ratio is mark worthy. The answer was already given. So we don't get a mark, but we need to bring it home. Okay. Excuse me, guys. Now we are doing fine. So we have our 5 marks and we essentially just move 1. So 8.3. 8.3 says we need to prove that AC when AC, we know what AC is. This long length. At this point, we don't really need to do anything about it. We need to prove that AC times BD. We know what BD is. It's this side. Okay? Is equal to AB. So we know what AB is. It's that side. So if you look, AC and AB are part and parcel of this triangle. Okay, most likely. And then we're going to have what? AC times BD. Okay. If we look at this, BD shows up in 2 things. So we'll see about that. Okay, CD. There's this CD here. So CD and AD. Phew. So it looks like we are comparing, by the look of things, it looks like we are comparing actually ACD. We are comparing ACD and this big triangle. Yeah, that's what it looks like. And what is nice, we know that this angle is equal to that. Right? Right. And then we know that that angle here, which is that angle, is going to be equal to which other angle? Indenzani ngoku? Oh yeah. But yeah, this is what looks like we're comparing, is this one and that one. Oopsie. So we're gonna do this and see what happens. But now let's see, where is the similarity? Of course, I have those 2 angles. I'm happy. I said this one is equal to that one. Right? But this one is equal to wait a minute. We said that is equal to that, but is this angle equal to that? Interesting stuff. But that one is equal to this and that added together. But what about that angle? Yes, it's this, but is this angle equal to that? Maybe. That angle equal to that? Maybe. Ooh. Ooh. Okay guys, ngatifuna ngiqhela kakubi ke ngoku. Ifuna ukundiqhela. Ingiqhela kakubi. Ifuna ukundiqhela. Indiqhela kakubi. What we did above, guys, must help us, you know. I have a feeling now that I'm just bailing because this one is already done. There's something that we did above here that actually should be saying the same language. There is something that we said that should help us, you know. It's just that I can't think of anything right now. Yeah, man. We said this angle is equal to that, didn't we? Let me check above. Didn't we say that? E1, where did we mention E1? Yeah, E1. We mentioned E1. By the way, which triangles? AED, yes. AED and CBD, yes. So, definitely, that's the story. That's the message. Those ones are the implications or implied ones. You know, guys, but yeah, from here we know without a shadow of doubt that guys, I don't know, man. I send you a bobana, man. I'm not sure what's cooking. Why the finishing at India bobana, man? But I know that if this triangle is similar to that, right, which is what we did above, now this would mean I need to prove that this triangle is similar to that, right? How do I do it, guys? This and that are sorted, okay? That's fine. That's fine. The other thing that I'm thinking about, I can just go straight. In fact, instead of trying to compare any triangles, let's see if I cannot go straight into this. Let's see if I can't just go straight and then use these two. Let's see what happens. Because sometimes, yes, to prove the similarity might be painful. As you can see, I'm getting confused. But let's just take AC as it is. Sometimes in maths you can do that. AC times BD is going to be equal to, what is AC? AC is AE plus EC, right? Right, and then I'm multiplying this by BD still. This one is a set. I'm multiplying it by BD. I'm just going to do it directly. Now, AE is there. So when I isolate AE here, what do I get? BC times AD over BD. So this is the same as BC times AD divided by BD. Plus EC, when I manipulate this one, is going to be AB times CD over BD. This one is multiplied by BD. Now we can see that if we distribute this inside here and that inside, what happens? The BD will take the BD and take that BD. Now we end up with the answer. So this is just going to be BC. Okay, now they wrote it in such a, remember addition is commutative. We can start with this side as it is the case. We've got AB. Do you see, guys, the properties of natural numbers? Coming back, Euclidean geometry is not a different beast. So we've got here BC times AD. Done. Okay, so obviously here you probably want to keep it coming so that we can make the conclusion nicely. So sometimes, man, you use tricks to get to the answer. And of course, the mark allocation sometimes is a guide. It's a true guide, sometimes, not always. Let me say most times it is a true guide, but sometimes it can mislead because students end up in a curve out of commission. As you can see, you could still try to find how those triangles are similar. I'm sure there is a way to find out. It's just that my brain locked. Now I had to just look at it directly, because sometimes you can just look at this product directly and then use these guys to get around the corner, because you can see that there's a lot of those things in here. Okay, nice and easy, guys. So this is a smart move. I would say this is a mark there. The substitutions here also are good. And to still multiply by this, I guess, is fine. Easy 3 marks, however strange it looks. Sometimes it's not so nice, but if it is done, it is done, guys. So this is 5 plus 6, that's 11 marks. Again, it's typical of those crazy final questions in Euclidean geometry. So we're doing fine. Now let's get to this. Of course, guys, this video is going to be long, but I want us to end with this question still. Okay, I'm going to try to move quicker. I think you've been enjoying the analysis. Leave the page for some notes. So I want us guys to do more so that the remaining questions we can take down nice and sweet. Now you see this nonsensical branding that they do here, the watermark. We can't read now. In the diagram, as you see now, guys, in the diagram, FE is parallel. So here, this is FE is parallel to GA. And that's indicated, okay? And then BA is a tangent. So that's what that statement says, at B. Okay. So BA is a tangent at B. Okay, it's not a straight line. I don't like it. So good. So automatically, guys, 10 chord theorem. Don't wait for a second invitation. 10 chord theorem is our friend. And also this one matches what would be a 10 chord theorem. Good. Parallel lines tell us that alternate angles are equal. And more so, we can say corresponding angles are equal. And then co-interior angles are supplementary. Of course, guys, we avoid saying more than is necessary. So we just have to say enough. Okay, guys. Now, what do we notice also? So what you notice that this is a cyclic quad. Okay, that makes up a cyclic quad. So very easy stuff. Now, if that's a cyclic quad, we know that that angle will also be equal to this angle, the exterior angle of a cyclic quad. So always open your eyes, guys. Open your mind. Everything will look nice and easy. And try to keep it clean. Don't go too far. Don't do too much. Let's answer the question. Sometimes we may have to look back into the diagram. We need to prove that AB squared is equal to let's see, AB squared is equal to AD times AC. Of course, guys, this is true. For 3 marks, I can write the first question quickly and say, look, I know that it is so. I can just write AB squared is equal to AD times AC. All I know is that this is the tangent secant theorem. I don't know if you guys are allowed to do this. And if I did it, I can get a mark for this and 2 marks for the reason. No one can tell me you're not going to get it right. The tangent and the secant, we know that the square on the tangent is going to be equal to the product of the segments of the secant. We know that CDA is a straight line, so it's a secant of the circle because it cuts the circle at 2 points. And it goes to meet the tangent. So this is the case, okay? So this is how you can do it, but alternatively, which is perhaps the way that a grade 12 and grade 11 students are expected, but this theorem is very much applicable. Remember, this is within grade 11 stuff and grade 12. Yes, it may not be taught, but it doesn't mean it's not mathematical, okay? But let's go for it, guys. Now, what do we need to do here? We know that AB is here, AD is there, and then we've got AC, which is over there. So this is telling you and I that we're working with these triangles. So guys, we can see that we're working with these triangles. So you can see I've outlined the triangle, the big one and the smaller one. We are working with those triangles, and you can see the 10 chord theorem comes to our rescue here. Okay. So this one you can say in triangle, you can say ABD and triangle ABC. This is the standard approach, of course. So we know, folks, that in ABD, B1 must be equal to C1 in ABC. So this is the 10 chord theorem. Okay, easy. I need a second pair. I know that angle A1, can you see it's common? Is common to both triangles. So if I've proven 2 sets, I can easily say triangle ABD is similar to triangle ABC. The reason is angle. I don't need the third one. It's automatic. This completes the puzzle that says AB, a side in our small triangle. Now AB is opposite D4. D4 would be an equivalent, in fact, would be equal to B1 and B2 on the other side. It corresponds with that side. And the side opposite it is AC. Okay, nice and easy. This is equal to, again, I'm going to use this ratio. I know that AD is part of this triangle divided by. This is opposite that angle. That angle is equal to that. The side opposite that angle in the big triangle is AB. Again, we can just say similar triangles, or you can say proportional sides of similar triangles. So when we cross multiply, what happens? We get AB squared is equal to AD times AC. Now, what would be the stuff here? Statement and reason, good. The common things, we don't care. That is good. And that statement. The rest is history. Okay. So you can see though that typically this should be 4 marks because it takes noticing this, but yeah, it is what it is. Nice and easy. Now let's do 9.2. 9.2 says we need to prove that triangle ADG ADG is similar to triangle AGC. AGC, okay, the big one. Okay, right. So let's see, we are looking at this triangle and we are comparing it with the big one. All right. So basically, guys, we're comparing the stippled triangle and the shaded triangle. Yeah? So what do they have in common? Definitely this is obvious. They have this angle in common because angle A2 belongs to the stippled triangle. Right? It belongs to this triangle as well as the big one. So that's the first thing they have in common. But the second thing they have in common is this other angle. Can you see that angle G2 is equal to E2, alternate angles with these parallel lines, but that equaling that because of being the exterior angle of a cyclic quad. It's a bit of an indirect connection, but once you have two angles equal, we know that the third pair is going to be the same, meaning D3 is going to be equal to that angle. In fact, it is. We can still use the property of this and say that angle G1 and G2 is equal to F2, corresponding angles, but this and this should be equal as well. Why? Because this is an exterior angle of that cyclic quad. So you've got options there. Either you choose 2 or you prove 3, it's up to you, but I don't like to give myself extra work, so I know that in triangle ADG and triangle AGC, all I know is that A1, so A2 is common, right? Secondly, I want from the small triangle, I know that G2 is equal to E2. These are alternate angles with GA parallel to FE or EF, okay? I've got a but. I know that E2 is equal to C2. Why? This is the exterior angle of a cyclic quad. Now I can mention which one. It's CDEF. Always try to be specific because you might be lying through your teeth. So from here, guys, we can make a conclusion that wow, G2 is equal to C2. That's what we wanted. The link is E2. The link was E2. So you may say each is equal to E2 or you stop there, but I would like sometimes to still state each equals angle E2. For someone who just didn't follow or perhaps got distracted so that they don't sink me, take my marks away. Now once I've proved two sets, guys, I can conclude that triangle ADG is indeed similar to triangle AGC. I've just proven two sets. They're good enough. There's no need for the third because it's in any case going to be a deduction rather than a proof by itself. Right, so we're scoring how many marks here? 5. Okay, this one is good. We will get this one because it's quite good. We get that one, it's quite good. We can then key it. We get a mark for that statement and reason. In fact, 2 marks. This one is essentially something you should be aware of after saying all that you said. and then we get a mark for the reason for the answer. See, 5 marks, guys, in the bag, just like that. No need to sweat. Now 9.3 says we need to prove that AG is equal to AB. Okay, so we want to prove that this side is actually equal to that side. Now obviously we already know what AB is, like that, so we already know, we have that in the bag. So this means we need to use these 2 triangles that we just proved similar. We need to prove that this side squared, because it belongs to both triangles, this one and the big one, that side squared we need to prove is equal to the product of AD times AC, which we can. So we know that, okay, we're going to start GA over GA in the smaller triangle is opposite D3, which is going to be equal to that. The side opposite that is AC. Right. This is going to be equal to, now I want to use AD still. This is a strategy. Now AD is opposite that angle is equal to that. The side opposite that is GA. Now we can just say these are the proportional sides, similar triangles in 9.2, just to be specific. Now folks, we want to say that when we cross multiply, what do we get? We get GA squared is equal to basically AD times AC. Therefore this means GA squared, did we start with AG? Now we can start nicely and say therefore AG squared is equal to AB squared, isn't it? Yes, because each is equal to AD times AC. We saw that above. We already spoke about AB squared. So now when we take the square root, the gymnastic is just to do this square root. What you do on the one hand side, you're going to do. So this concludes that indeed AG is equal to AB. Don't forget, we still take square roots. We have to show that. Otherwise, this is easy 2 marks, guys. So this one is a statement and a reason. And then this gymnastic here, it's more important. The answer was already being suggested, so we don't care about it. All right, so that's it, guys, for that question. 9.4 says we need to find AG. Oh, sorry, AG is 6 units and AD is 4 units. So this is cool. So this is 6. Superb. AG is 6. And then this one is 4. Okay. Now we need to calculate the length of DC. Okay. So that's not a problem. Where is DC? Is this one. Okay. So we want the length of DC. How to it's 2 marks, guys. It's easy. We're gonna use any of the things we've done. So we can use this equation that we found. It makes our lives easy. Or we can even use AB. It's not a big deal. So let's just use AB. But AB looks too far away from this. Let's just say GA squared or AG squared is equal to AD times AC. We said proved above. Specifically, we did it in 9.3. So that we are clear that we are not copying. Remember, guys, it helps to also showcase that what you are talking about is what you are seeing yourself. And it's evident. Remember, sometimes I ask you, Where is the evidence? So sometimes we want it, because when you are investigated for copying, trust me guys, the quality of the answers you provide can spare you from the problem, and this can affect your future big time. Right, now we know that GA is 6, so we're going to square it. AD is 4, but CD, we know that CD plus AD gives us AC. Right, so instead of AD here, we write 4. Nice and easy. Now folks, we can do our thing. This is 36 equals, we distribute the 4, we get 4 CD plus 16. So this means 4 CD is going to be 36 minus 16 is 24, right? Therefore, CD is going to be 6 units. Oopsie. Erroring. I think the body, I think it's 20, guys. Isn't it 20? Yeah. Should be 20, not 24. It's even younger meteg, so this is 5 units. Okay, that sounds right. Yes. Why bonus in 20? So guys, sometimes you're gonna be asked these numerical values of things. Easy stuff. So perhaps I would give a mark for that, because that was a smart move. The rest, that was 9.4.1. Again guys, pay attention to the numbering. It can haunt you all the way. Right, so guys, we're moving nice and slow. Of course, we've got just about 2 questions to conclude. We will do the rest later. I wish we could easily get to 13, but we can't. But there's not a lot of questions left, so we can take down the others. Ooh, there are so many. But yeah, we can't do it in one go. At least if we do the 11 questions, I think we'll have done some good. Then the others, I can try to rush through them, hoping that you're gonna, follow. And it says if the length of GD, okay, we want the length of GD correct to 2 decimal places. Can you see we're being told? If CE is the diameter, we're given more information. Now where is CE? CE is not here, so we need to construct it. Okay, let's construct a diameter. Damn it, man. I'm just gonna construct it nicely. But this is not gonna work in my favor. But of course, I'm gonna do some gymnastics on it. We will see. We can do gymnastics on a line. I hope it's gonna be exactly parallel. See? The gymnastics are like these buffets. Okay, masithi uyilungisa kancane. Just a bit again. Okay. Yeah. I guess uniphaphela wena man. Mandingathi xa ndikunciphisa unganciphi. We made it. Although it's not so nice, but yeah, it is. So if this is a diameter, guys, and what are we looking for? GD. So we are looking for you, sir. We're looking for GD. Right. And we're told CE is the diameter. What do we know about a diameter? It subtends a right angle. That's what we know. So this is a right angle. Okay? If that's a right angle, sinceda ngantoni? Sinceda ngokuthi sokwazi ukusebenzisa uPythagoras. Now if that's 90 degrees, angles on a straight line, this one is going to be 90 degrees. So angles on a straight line. So then it tells us that our triangle is a right angled triangle. So that was the information. Now we know that this is 4, we know that this is 6. We can use Pythagoras. Great. So we're going to say fine. We know that first and foremost, D4 is going to be 90 degrees, right? This is the angle in the semicircle. Okay? Because CE is given to us as a diameter. Now, what is the story? The next story we will say here, well, but we know that D4 plus D3 should be 180 degrees. These are angles on a straight line. Please guys, don't jump and say, therefore D3 is 180. I mean, D3 is 90, and then you say angles on a straight line. There's no such sense in that statement. Yes, we know what it implies, but are we sure that you are doing this or you're copying? You're probably copying, so this implies that this is 90 degrees plus D3. I'm showing you to be meticulous. Don't overly summarize. Sometimes summaries are not palatable. Now only here you can make sense to me that this is 90 degrees. Okay, now I know. Although I wouldn't have known had you not shown me. We can say then, we know that essentially AG squared is going to be equal to GD squared plus AD squared. This is from Pythagoras. In triangle ADG. I need you to be specific, guys. I need you to be specific. I know that you're talking Pythagoras, but where? Where? But sometimes I may not even know why you're looking for D3. Why? Now when I see that, okay, you're talking about this being a right angled triangle. Okay, I see. So this is C squared equals GD squared plus this is 4 squared. Now this implies that GD is going to be the square root going to be the square root of 6 squared minus 4 squared. Therefore GD is, now this is 36 minus 16. 36 minus 16. Yes, it's going to be root 20, Baba. Now root 20 is 2 root 5, but we need a decimal place. Okay, let's just put it in the calculators. So we get 2 root 5 to 2 decimal places. This is 4,47 units. Remember, every time you calculate a distance, you have to show us the units. Okay, guys, so this is easy. So obviously this statement is powerful. It was intended here. And secondly, to prove that D3 is 90 degrees, I think it's commendable. The rest is your problem, guys. We cannot mark you right for Pythagoras, never. But we want to see it. All right, folks, so that is how many marks here? This is 5, 10, 12, 15. Okay. This is again typical of those longish structured questions towards the end of an exam. Usually this becomes the last question on Euclidean geometry. Okay, let's take down question 10. Okay, we tried, guys, to be as medium pace or even slow pace as possible, but now I'm going to try to not be smiling with you. In the diagram, PQRST is a cyclic quad. We can see all four vertices are at circumference. It needs no introduction. QM times PS is equal to, now this one, QM, this, times PS, that, is equal to QR, this one, times RS. Okay, so this is suggesting that two triangles here are similar. Now, which triangles? Yes, you saw them. All right, you saw those triangles. As you can see, the outlined triangles. Can you see that side and this side belongs to this? And then this side and that side belongs to that triangle. So sometimes with proportionality, you will be given the sides in proportion. Then you have to deduce the triangles to be similar conversely. Yes, this is the message. And we're also given further that QM over RS. Okay, QM over RS is equal to R. Okay, that's all right. Now it says we need to prove that QR, we need to prove this. Okay, this is just 2 marks. We don't need to go far. We're going to take what we were given, QM times PS is equal to QR times RS. Now what we want is QR over SP or PS, whatever you call this. So you might as well call this one PS. There's nothing wrong. Remember, multiplication is commutative. We can move S in front or after. It's not a big deal. So what are we trying to have here? QR over SP. So this means we can divide by PS times something. Also here PS times something. So what do we not want? RS. Remember, in maths we can do anything. Okay, maybe let's start by saying this. This was given. Let's not be hooligans. This is given. So this implies that, of course, if I divide by anything I want, I would have QM times PS equals QR times RS divided by, I want RS to be out, but I also want PS down here. So I'm going to do the same here. I'm going to have PS times RS. Yes. And then this dude divides that. That dude divides that. So what do we have? Super. Is that one and this one. Yeah, so this implies that QR, which is what I want, over SP or whatever, PS, SP, yay, injalo lonto. This is going to be equal to QM over RS. Therefore, QR over SP or whatever this is, what we were told, that is R. Nice and easy. Okay, so this is it, guys. Just 2 marks for the gymnastics. I mean, that's the one. And then, of course, whatever, replacing, you call it. This one, I would give 1 mark, to be honest, not 2, because it doesn't make sense. Everything else was given. Marae. Yeah. Maybe the mark is here. Buffets. Because to know that this is what it's going to be, I think was key than the substitution. Okay, 10.2. Of course, guys, I said I was not going to go more than 3 hours, but we are on the 4th hour. Hence, prove that MR over RP. MR, let's choose a different color that we can see. MR over RP. See, inside you don't want, yeah, but be careful though, make it nice and clean, guys. If you've got a thin one, you can make it thin. Even here, you can make it thin. Remember, in the next 5 years to 10 years, you'll probably be doing this on a tablet. You'll be writing your answers on a tablet, annotating your diagrams like this. So you might as well learn how to use gadgets, eh? Because sooner or later we're gonna give tablets, because we're tired of kids carrying books to school. You see, a tablet like mine, I think it's gonna be the standard for schooling, but of course I'm gonna try and strike a deal with Samsung, because I think Samsung is durable, it's waterproof, and it's easy to use. You can expand the storage, unlike these Apple things, which terrible anyway. Even to use it is ridiculous for me. And besides, Samsung beats Apple by a country mile in terms of being user-friendly and high quality. But you can go and buy your Apple. Just buying the name, it's expensive for mahal. Samsung is expensive for the real reasons, guys. It offers you things. So I think you should have this, because you know why I'm saying this. I'm going to show you at the end why. Let's just get to business here. Now, MR is part of this triangle, and then this RP is part of those two triangles. Do you see? These are the triangles that we needed to prove that they are indeed similar, and we can see that these questions were actually trying to drive us into this. Do you see? This thing is talking sense in terms of that as well. Now we can say, well, in triangle, you need to see this, guys. It's not so obvious. In triangle, MQR and triangle PRS. What do we notice, guys? We can see that MQ over RS is essentially equal to QR over SP. Now this is proved above, or it's even given. You can even say that given, but we can see that each is equal to R. Let's just try to pretend that we didn't know that. When that statement was given, we could manipulate it so that this is the case, as we would have done here. From here, if this is the case, guys, in two triangles, what does it mean? It therefore means the two triangles, triangle MQR is similar to triangle PRS, because the sides are in proportion. If any two triangles have their sides in the same proportion, automatically it means those two triangles are similar, straight up. Now this implies that we can take any pair of two sides in proportion. Now what are we interested in? We're interested in this MR. So we can choose MR from the other triangle. MR is opposite Q1. Q1 is going to correspond with which angle in the other one? It's going to correspond with this, isn't it? Because this is the exterior angle. You see, Of course, they didn't tell us much, but we can assume that that is a straight line. That's an exterior angle of a cyclic quad. So they will correspond. Of course, I know they will, because if I have MR, ne? Okay, let's not say much, but I could do it another way, but to prove that this is going to be in the same proportion. I mean, it's not a big deal. MR over this one. Opposite that, this is PR or RP. Must be equal to any of the other sides that we've already proven. You can choose MQ. MQ is opposite this angle, and we know that this angle corresponded with which? With this one, which is going to be PS. Is it PS? Yay, Mawena, Mawena, Uzandi Bobani Sawena. Okay, let's see which sides. We can go back, man, and choose any of these other sides, right? QR, actually, we don't need to choose other things. We can say QR and SP. You know, why not? I think so I can say QR over SP. Why? Because QR is this one. It's opposite that angle. That angle is then somehow equal to this, so that we can have SP. You see, it's very strange, but it is what it is, guys. I can say similar triangles. This one was a bit ridiculous if you ask me, but hey, sometimes bafethu injalo. So we can see that indeed MR over RP. Some things are a bit weird, because we already proved that this is so. Some things are a bit weird. Are they weirdos? So this is good. This is good. I do think here statement and reason 2 marks. Yeah. The rest is as you love it. Yo guys, I'm feeling dizzy now. I need to sleep. Go late, and I'm working today. Was ndinale hip engibulalayo ngepain. Yo guys, but at least I try to relax a bit. Hey, in the past few days, in fact last week, yeah, ekunzima nokuphakama ndetoilet uthi ndikhale. Ndinenza classes nje, guys. I feel like crying, you know. At least now it's better, but if I sit for long, when I move, it's like I should just maintain the position I'm in and not change. The change is so painful. I've had this thing in my 4th year at medical school back in 2009. Yo, it was my knee that time. God, it killed me for 2 weeks. I was dying in my place. I could not attend lectures. And this thing was not swollen. It was just a stiff joint, painful. Whether I'm sleeping or I'm awake, it didn't matter. And I was not the guy who believes in taking medications. So I kind of sat through it without taking anything. Just try to, use warm cloth. But sometimes it preferred to be cold. Yo, I don't know what was happening that time. Then at the end of the 2nd week, now I could walk a bit better. The joint started swelling, just like this hip, although it's hidden, but I can feel a bit of, some fluctuancy there. So it started to fill up with liquid, and then it was better. I could move a bit. Now remember, guys, I've been eating bread and tea and a little bit of what is in the room because I couldn't walk to the cafeteria. It's far away and you cannot make a room service call. So You know, my friends, yes, a friend of mine, Mtsepana, did help every now and then, but of course I couldn't rely on him because we're in different classes, so we had different commitments. So my neighbors are not the people I could trust to, do things for me, because two of them were my classmates. Anyway, so I was like, okay, oh man, I've been hungry. I just want a full meal. So I finally could walk to the cafeteria that Sunday. Oh, only to bring myself a mayhem. I got food poisoning from that bloody meal. Now I had a running crampy tummy. Now with my knee not really 100%. Yo, I couldn't take it anymore. I felt like I'm going crazy. So I called my friend that Baba there was a friend of his who had a car. So I was like, call your friend, Boza. He needs to take me to the hospital. I cannot cope anymore with this tummy and this knee. Remember, now I need to run to the toilet. And I can't because my knee is doing its own knee things, So they took me to the hospital. I remember our university hospital is George Mukare at Medunsa. So I trained at Medunsa. So they took me to George Mukare. Well, they saw me there, injected me, gave me a drip and all. Now I mentioned this knee. I made a mistake. The casualty officer referred me to the orthopods. The orthopods admitted me. They want to operate on this knee. But I'm like, come on, guys. The knee is not the reason I came to this bloody place. I came here because of the food poisoning that was worsening my situation. My knee is healing already on its own. They're like, no, we just want to see. And then they did x-rays. They didn't see anything. So they said, probably had a hemarthrosis. I remember I was playing soccer at that time, so I may have gotten injured. Maybe I twisted my knee. I didn't notice. Maybe blood was there. Remember, clotted blood sometimes doesn't, you don't notice it's there. But the moment it dissolves into this yellowish, we call it a xanthochromic stuff. It becomes xanthochromic. It's the hypoxanthine, one of the degradation products of the red cells, the hemoglobin molecule. So that thing, guys, it's a serious irritant to excitable tissues like nerve endings and stuff. Now that's exactly the problem. So it looks like I may have injured my knee during a soccer match, and this can happen like a week before because it takes about 7 days for a blood clot to start dissolving. Maybe that was the reason, because you could see that maybe the blood was largely clotted at the start because it just was painful without any swelling. But then the swelling started later on, maybe when this liquid now started secreting there. So I'm suspecting this is the same because I'm a motorcyclist. Maybe when I took my turns on the bike, I had my hip joint. Sometimes I lift patients on and off the table when I operate. That could have been the injury because I started to feel this when I was on duty, moving a patient to the CT scan. So maybe it started there. Yeah, sometimes guys, look after yourselves, eh? It's dangerous out there. At least try to know what happened when you have a problem so that you don't jump around, end up with treatments that you don't need, and yet they're going to hurt you. Okay, hence deduce that MQR, come on man, what are you doing? Hence deduce that MQR and RSP are similar. Yeah, doc, come on now. I've already used it, man. What are you doing? I've already used it. This question is strange now. You can't. I've already made the deduction. That's the only way I could move forward. Was there any other way one could move forward here? No. There was no way. So what is this now? You see these questions? It's crazy. These questions are not I don't understand. Come on, guys. What are you doing now? I've already made it. Well, triangle MQR is similar to triangle RSP. Sometimes you ask stupid questions, then we can just give you stupid answers because MQ is equal to RS, but this is ridiculous, which is equal to QR over SP, which is now equal to MR over RP, whatever. This is ridiculous, honestly. 2 marks for what? How could you have done 10.2? Maybe I'm stupid, guys. Sometimes I think I'm smart, eh? Only to find that I'm a dumb cop this thing. A dumb cop writing. Forget it. You know, sometimes how you can convince yourself you're smart when you're actually a dunderhead. Maybe I'm that guy who's a dunderhead and I think I'm smart. Okay, guys, if you see any reasonable explanation for this question, please highlight it to me in the comment section if you want. Or you can just touch me privately if you're afraid of showing up. You know, don't be afraid to be wrong, guys. You just have to say things, okay? Sometimes speak your mind even when it's going to hurt others. They just have to deal with it, okay? If it's not your intention, your conscience is clear. They can cry all they want. If your intention is clear, God only knows. They will never know because people are situational and consequential in life. You know? There is a story circulating. I'm not going to say which one. The story is quite scary, guys. But now when people who are using their heads in this thing, they're asking some questions. People are catching feelings and, you know, trying to bash those people, and they're even trying to cancel them. Just because these people don't seem to just like them automatically fall for the story. I can actually relate with that story personally because I've seen some scary things that sound like a movie happening in my own life. And of course, those are not things I would tell you guys or the public because it has nothing to do with all of you. But yeah, I've heard such. You would think it's a movie when I explain this, but it's actually a reality. Of course, to a bright mind, a discerning mind, someone who uses their logic instead of their feelings, they would start asking questions. Yes, some parts of my story sound a bit too easy. Too good to be true. Sometimes they look too convenient for the situation. And as a result, guys, this thing has really put me in a very precarious position. You know, sometimes you find yourself unsure of the way forward because everyone is against you because they think you are creating stories. They don't realize some things you only understand if you go through them. Even when you do, you will still not believe you've just done that because somehow you think you are crazy. You don't believe yourself at times. So, you know, some guys are asking some nice questions, you know, and people are catching feelings. So this is the same thing as I'm saying. Look at these questions. I'm catching feelings too, but you may find that I'm wrong, you know. But I'm not afraid to be wrong, guys. This is why I speak my mind for all of you to hear, especially on things where I have to apply my mind. But being wrong is part of life, because if I'm wrong about it, then I will have learned something about being wrong. It doesn't mean now go and sit in a corner somewhere and cry out to God. No. In life, sometimes you miss the point, but at some point, certain questions lead us to the correct answers, because some people are liars, they are manipulative, they can create any story to get themselves out of a pit. Only later you realize, wow. Take for example these people who posed as, take that lady, Mary DeHaas, what's her name? Yeah. She posed as this intellectual with these degrees, only to find that she doesn't. But at first value, when you found her in a young age, when she was still eloquent in everything she does, she was excellent. There's no question about it. But as excellent as she was, she has been devious, unfortunately. And look how it comes out now. Comes out when she cannot correct it anymore. So you don't want that in life. You don't want to be embarrassed forever. Rather be embarrassed for a moment when you can still do something about that embarrassment. But go out in style, okay? Oopsie. These ones were lousy questions. Maybe the first two were fine, but the last one I'm not happy. Nah. Okay guys, let's do the last question and call it a break. It's been too long, so I thought I was going to be able to move fast, but I couldn't. But I don't want to sacrifice, a chance for you to learn over trying to finish the video fast. If you guys don't like it, you walk away. But I can tell you will never learn anything if you don't have patience in this life. And it takes patience to become better and faster. It's like when you're training for a sprint. If you train by sprinting, you're going to exhaust your muscles. They're not going to shape up. They will just be tired. You're going to undergo glycolysis and anaerobic respiration, and you will start accumulating lactic acid in those muscles, and then you're going to be tired, okay? And the more you keep doing this, you're going to scar those muscle fibers. Then they're going to start shortening, and you'll be unable to really do things fast. So when you want to train to be fast, you actually train by doing it slow, because you want to build endurance, strength, and flexibility. Then towards the main event, then you start sprinting, and you will see that you will sprint better and you will last longer. But if you start sprinting thinking that sprinting every day is going to make you win the competition, you are going to fall off. I promise you, you're not going to keep up. You're not going to keep up, because your body is not going to have the patience for what you're going to try to force it to. So sometimes I'm giving you these lessons, guys, as long as they come and in a very slow pace as possible, so that at the end of the day you get there. Of course, if you have no patience, there's better channels for that. There's people in this platform who do quick answers for you. So go to those platforms. You're going to learn, of course. I hope so. I hope you will learn. Because there's nothing better than understanding what you're doing and how to get things done, than to just see things being done and you think you can do it and then you crash out. Okay, all right. You make the choice. I don't want to say too much. In the diagram, KOC is the diameter. If KOC is the diameter, this is 90 degrees, because this is the angle in the semicircle. Ayiphumanga kahle yangicaphukisa sikantina wena man akidiphahlo nna akitinwi nna hauna moto tlantinang. Now folks, look at this thing. If we just look quickly, we can see that BS is equal to SC, but we also know that the radii are themselves equal. So any line that joins the midpoints of the opposite sides of a triangle will automatically or deductively be parallel to the third side. But now this is the midpoint theorem in grade 10. You see most. Right. Now KA is a tangent. It's tangent. What do we know about tangents and circles? We know that tangents are themselves perpendicular to the radius of a circle. So a tangent is perpendicular to the radius. Any line from center to the tangent will be perpendicular to that. 2. We know that this angle K1 is equal to angle C. 10-chord theorem. That's the 10-chord theorem. Now we know also that when a line is drawn from the center to the midpoint of the chord, that line must be perpendicular to the chord. Oopsie. You see when you have the 8, 4 guys, you can already tell that even from just that, you would have made a deduction that this is the angle in the semicircle. This is the line drawn from center to midpoint of chord. Now, if cointerior angles are supplementary, the lines are parallel. So you've got lots and lots of reasons to get to that parallelity. Now, AC intersects the circle at B, right? We see that. And then we're also told that BS is equal to SC. We've already used it. Then KB and OS are joined. Now, KB, OS are joined, so that means those are straight lines. Okay, let's get to business quickly. 11.1 says we need to prove that CO, okay, masiqale sijonge bisuka phi. CO, where is CO? Is the radius. CS, what is CS? Is this portion here. Now let's look again. CA, uphi wena CA, sisuka siyele kude. Then ibe sehamba no CK. Jo. Reja joy CK. Xa sijonga siyaphaya. So le nto ithini namadoda? Maske sijonge futhi. There's a CK here. This one is that whole side. There's a CA and it's that whole side. And then there's a CS or SC, yes, and CO. Okay, all right, okay. So what is this trying to tell you and I, mntwana esikolo? Isixelela into yokuba sicomparisha le triangle. Ne? Ndigqibezela ngoku. Sicomparisha leya nalo mancane lo. Kumancane nomuntu omkhulu. So nazi izinto esizithelekisayo. When you in isiXhosa ke, when you compare, sithi yazithelekisa. Uyaqonda? Uyazithelekisa. Sijonga, compare and contrast. Ukuthelekisa kuphinde kube ukuqhatha ngesizulu, as in xabanisa. Yayiva ke ngoku le nto. Xhosa ke sinayo into kuthetha ngento enye, igama elinye lithetha into ezimbini ezahlukeneyo. Yayiva ke ngoku le nto. Yilaa nto esiye sithi ke ngoku ngomabizo afane kodwa abe engathethi into enye. Akuyoze zithetha ntonye, i-synonyms ngesilungu. Yayiva ke ngoku le nto injalo. Now sesiyayibona yonke le nyakanyaka uba hayi man. Le nto lena sizawuyilungisa lena. Le nto lena sizawuyilungisa kakuhle nje futhi. Kakuhle nje ngaphandle kweengxaki ezininzi. Sizawuzithelekisa kanjani ezi triangles zethu? This angle is common. Yes, it is very much. But now we're going to use our theorem to prove that this is 90 degrees. We're not going to use the midpoint theorem, but we can use it if we want. I mean, there's nothing wrong. Use the midpoint theorem, or we're going to use this one. Let's use this one. Line from center to midpoint, perpendicular. This means our S1 is going to be perpendicular, it's 90 degrees. And then here we're going to use tan red. So if we've got two sets equal, the two things are in the proportions. They are in the proportions. Although this is 3 marks, it's hiding the fact that, guys, we have work to do. Okay. So we're going to say in triangle COS or SOC, surgeons on call, and triangle ACK. Okay. Now, don't be afraid. Don't worry about the mark allocation. Just get the job done. Now, what do we know? We know that angle C is common. Right? Now, the next thing that we want to talk about, we know that, hey, we know though that S1 is 90 degrees. Why do we know this? This is the line from center to midpoint of chord. It is, if a line is from center to the midpoint of chord, it bisects the chord. That was given. We're not gonna say a lot. We can say likewise. We know that basically AKC is also 90 degrees. Why? This is the tangent perpendicular to radius. Okay, so this concludes that S1 is equal to AKC. Each is 90 degrees. We can now say therefore triangle SOC is indeed similar to triangle ACK. Angle, angle. We just need two pairs. From here we can make a conclusion that yes. CO of the small triangle is opposite the right angle. The right angle is equal to that one. The side opposite is AC or CA. Is equal to, we look for the other one, is itheni wengathi ufuna ngiqala kakubi ngo ingathi ufuna ukundijija mayingandijiji andifuni kujijeka. Itheni ngathi ufuna niphambanela ngo itheni sekuno CA kwela cala u-CK ke ngoku yena hayi bo bafethi mani kancinci ngoku theni nangoku this side is opposite that is equal to that. The side opposite that is good. Kodwa khona into efuna uniphambanisa ngoku. U-CA uvelaphi yena? No-CK. U-CK, okay, maske siqale kahle. Khona into endiyibonayo engathi ifuna ukwenzeka but izawunimosha nayo ndiyijongile nje. Ikhona into efuna ukundenzekela apha. Let's go guys. This is SC man. Kodwa itheni lo SC ezayovela pha? Hey, ayisahambi zona. Okay, mhlambe siqale kakubi. Andifuni kanjena man. Let's start again. Let's start with SC or CS over. CS is opposite that angle, right? Now, that angle is going to be equal to that, and the side opposite that is CK or KC. Right? Right. Now, yey wena ubatla nketsang wena ke a wona ubatla bapala ka nna wena CO hayi akina choice. Hey, this question is turning up to the heights of me now. Wow, what a wow. Anyway, let's not be afraid. We are the masters of our trade. Now let's say CO is opposite that one is going to be AC, right? Or CA, as they put it. Okay, we can say similar triangles. Now I don't want to say a lot. I'm already angry. We're going to cross multiply. Don't rush. Sometimes, Marife, you must not run. Marife, you must not run. This also tells us that we've got CS times CA equals CO times CK. Now I've already got CA and CS on either side. So these ones are where I expect them to be. I'm not going to manipulate them. Now what we need to manipulate is in here. Now if I'm looking at CA is fine where it is, okay. Okay, it looks like what I don't need to manipulate is CA. But these other guys need to be manipulated, unfortunately. Now let's look. What do we see, guys? If I'm looking at CK, or let's just say CO, I can manipulate CO. CO is half of CK. So I'm going to say that, but I know that CO is equal to half of CK, right? Or KC, whatever that is. Now we know that this is a radius. A radius is half the diameter. Okay. Ke batla ho bona jwale hore ho tla etsahalang ha ke se ke etsa ka tsela ena. So this implies, Bafethu, that CS times CA is going to be equal to I sense zona ke manje. Yo. CK squared over 2. Hayi wena question kanti ndenza ntoni ngoku? Intoni ngawe kanti? Intoni ngawe? Yo, I think ndikhethe i-triangles ezi-wrong apha. Yeah, I think I chose the wrong triangles to compare, although they are similar, but yeah, is one harass le nto le. It is about to harass me. I think I chose the wrong triangles. Okay. It's Vanessa Papa, guys. We chose the wrong triangles here. I span. Nabas ngai chiga sitting. I span. Lo ho ba re ka etsa jwang kapa jwang ha e dumele. I think I chose the wrong triangles because, you know, because, hi, guys, tell me I'm a span length. Chin number 14. Chin number 14. I just get it all go wrong. There was 3 marks I saw zibende kangaka noba sekuthiwani tyhini yintsangutsangu kaloku leyo yintsangutsangu leyo sendirhalela leya yetangent tontons hey hayi sendirhalela ukusebenzisa i-10 sec theorem ngoku ngathi 10 sec theorem yami izawundisebenzela bona yonke guys ndidikiwe ke ngoku avele ngicaphukisa nansi into bo avele yandina yazi avele yandina awuthi sitshintshe nje amagiya bafethu akho nkinga ACK siyamyeka yena but let's take KBC or BCK awukhe sithathe le yasibona uba kwenzakalani. Now, okay, let's take this one, the big one, and see what happens. Still, angle C is common. Right? 2, what do we have in mind? What we have in mind is that this angle B1 is 90 degrees. This is the angle in a semicircle, right? But we also know that AKC is 90 degrees. This is the 10 rad theorem, right? Now, what is the story? Therefore, triangle BCK is similar to triangle ACK. Angle, yabona ngicaphukisa le question, yes? Yanhlanyisa man. Ingetsa sehole biyano. Now let's take that one. We're gonna say BC divided by. BC is opposite that angle. That angle will be equal to that. It's gonna be KC or CK equals KC. Yabona. Siyabiyeka KC. Hayibo guys. Iyaqhubeka lento. Hayi. Angisazi. Khathi siqale ekuqaleni futhi. Hayi ingathi ufuna ukunidida ke manje. Athi sithi KC futhi. Sithi KC over, or let's call it CK. Yabana. Hayi jwale ntweni ebapala kana jwale CK over. This side is opposite the right angle, right? That one is equal to that, and then AC, when CA, chartered accountant, is equal to. Now I'm gonna choose BC. So you see what? BC is opposite K2. K2 is equal to that guy, right? And then that guy is opposite CK. Hey, isaqhubeka idlala ngam. Wayibona na? Hayibo guys, kanti into ngale question ngoku. Kinga wena. Of course, we're gonna say similar triangles. And as guys, I'm feeling like koninto engayenzi kahle la. Awuthi sike manipulate la. We don't want CK on the left hand side. CK is 2 times CO, right? Over CA siyamyeka kanjalo. Why sisitsho njalo? CK masiyibona i-diameter le. CO is half of that. So 2 times the radius gives us the diameter. Now BC, siyamfuna BC? No, asimfuni. BC now is 2 times SC, whatever this is. All divided by CK. Yo. Hi guys, itheni ngoyangaphumi? Why yangaphumi? Oh, crap. It's not what I'm looking at, guys. This is a ratio. Ooh. This is a ratio, man. This means CO over CS. Damn it, man. Ndixakiwe kuthini ndingawini. Kanti ndibhala inyama. Hayi, man. Yes, man. Ndibhala inyongo. So this thing is the same as this. Oh, Lord. Wayibona ntwena, CO over CS is certainly going to be, CO is this one, and then that would be that one. Yeah, man. Our first plan was good. Banna we. Intro la hampe ntwena. Wa tseba intro etse hampe. Ho fetisisa. Empa ha ke no khotlela morao jwale. Ke tswella pele bana ba modimo, ke tswella pele. Empa ke tshwere jwale, ke tshwere mo e leng nyane teng. Ke tlo etsa ka tsela ena. Ke tlo ha ke qeta mona re tlo etsa and the small one it tlo ba ck okay, divided by, now re tlo re ck divided by bc or cb. Wa re nka this side re divide ka that side, e tlo tshwana le eng. Now re tseba hantle hore ck wa rona is opposite the right angle. This one is that, it tlo ba ca on the other side divided by, now re tseba hantle hape hore bc wa rona correspond a leafing angle. This is opposite that, that is opposite that, it tlo ba ck on this side, right? Then it tlo bapala ka di gymnastics. Re tseba hantle hore ck on the other one is basically 2 times CO over BC is 2 times SC or CS equals CA over CK. Now 2 takes the 2. Therefore CO over CS is equal to CA over CK. Now we can make it the way they wrote it. CO is 2, that means divide. I didn't notice that we've got colons there. My head twisted so much for nothing. But guys, it's nice when this happens because this teaches you and I something. Okay, it teaches you and I something. Okay, so that is it. You can see that sometimes got the same sign, but you can manipulate it so that it suits exactly what we wanted. These guys are crazy. They can't be calling me now. They are playing. Yes, I'm on duty today, but my duty starts at 8 a.m. not now. Right, so they must just chill. I'm not interested. So you see those 3 marks, I think at some point, guys, this statement and reason is good. This statement also is good. Without it, it doesn't make sense. And then this conclusion is mandatory. This statement is mandatory. This manipulation is mandatory. So I don't know what ganja the person who created that question is smoking. But whatever they're smoking, they're fine. But anyway, with these revision documents, be careful, guys. The persons who compile these, because there's so many questions, they end up putting wrong things. So there's even a chance that some questions are not solvable. Okay, there's a question on algebra that my students presented in the WhatsApp group. Actually, that question is not correct because the answers proposed by the memo of this document. This document has a memo at the end. But sometimes you may not understand the memo because they don't show the workings. So this is the purpose of you and I revising on this document. But now what I saw is that every time I solve that, I don't get the answers they proposed. But then guess what? You take the answers that they are proposing, go and substitute into the equation that they gave us. You see that the left-hand side is not equal to the right-hand side. So that's already showing that the solutions they have given are not actually the solutions to the problem presented, which means there must have been a misprint or mistyping. So don't get frustrated when you can't solve it. As you can see, I mean, it could easily be one of those, but I was actually reading the question incorrectly. Okay. So just take a moment and think about it. I don't know why these people must stop calling me. Yes, I'm on duty, but from 8 a.m., not from 4 a.m. So that means the one who's supposed to be on call is not answering the phone, and that's a problem. There's people who do this sometimes. They don't answer their phones because they don't want to get involved. But unfortunately, if I answer and then it's a resuscitation, then I'll have to go there. I mean, and yet there's someone who's supposed to finish up their duty. It's not mine. Even though I can do it, but sometimes you don't make it too easy for people because they become complacent and they become your problem. You end up answering. Sometimes I find that this case ends up in a litigation, you know. Sometimes, as much as ba imfundiso zasemakhaya zisitsho njalo, but inhliziyo enhle izakufaka enyakanyakeni uthi uyanceda kanti usifaka enyakanyakeni. Take for example a doctor who's going to say so and so was sick, like those people who come in your practice if you become a GP. They come here saying, doc, I need a sick note. Yes, they're going to pay, you're going to enjoy the money. And of course, you're not going to be difficult and say, no, I'm not going to write a sick note because you were not here on the time that you want the sick note for. But you just do it out of a good heart. You're thinking, okay, let me do it. And then the next thing, you find that that person was convicted. It comes up now in some court when the company that this person works for takes him to task because they have records now that this person was actually detained and in fact he stole from the company. Now they'll say, bring in that doctor who wrote your sick note. So be very careful of these sick notes. If of course you become a doctor, don't write sick notes for someone who didn't come just because you want money. Don't get involved, guys, in fraud. People need to take responsibility for their problems. Because sometimes they do this deliberately without considering the consequences. And they have to learn the hard way. Because if you try to save them, you will lose your career. Look at Advocate Batohi in that thing. She tried to be nice to people who were actually bad people. And she ended up sinking good people because of these bad ones who looked like they were desperate for her intervention, or at least they misled her at some point and she believed them. And at the end, she appears as someone who was bad. But you can clearly see that she's not necessarily a bad person. She didn't do most of these things deliberately, but she thought she was doing the right thing. So as I'm saying now, I can say, okay, I want to help my colleague and what. I run there, I do the resuscitation, and then end up with a mistake. Yes, my mistake. And then the family sues. Now, how will I justify being there when I was not supposed to be there? You understand? Now I'm going to put my colleague in a bad light that they didn't do their job. You see, at the end of the day, you are trying to help, but you may end up having someone, their job taken because, a mistake. Yes, it's a mistake. Nobody can go beyond it. It happens. Or maybe I missed something. It happens. But you realize if I let this be handled by someone who was on duty, they already know what was going on even before this moment. And now they will probably know of what to think and what to do, and it becomes the best thing that happens. Unless, of course, they are not reached, which unfortunately is beyond my control. So anyway, guys, I'm just trying to give you some ideas that even when you become whatever you become, be very careful of helping everybody and everyone at all times. in some moments you need to be selfish with your time. You need to be selfish with your resources. You need to be just a person who minds their own business. Sometimes it helps to do so. Although you can keep an open mind, you will know the instinct is going to tell you. Sometimes I use my instinct more than I use my feelings because I am taught to be a good person. I am taught to consider everybody, and it is in my nature to do so. But I've also learned the hard way. The people you are trying to help, they destroy you. And when they do, they don't smile. They don't laugh. And you are seated there thinking, man, I was trying to save this soul. And this soul is just sabotaging me instead. Takes away everything from you. And you know what? People like that are all around you. And then they forget that tomorrow, no one can prepare for it fully. We only hope that what we did today can help us. And indeed, most of the time it does, but it doesn't always do that. Okay, guys, enough the chit chat. I was just trying to show you. This question frustrated me, and I'm happy when you see the frustration happen because it makes you realize that it's not so easy after all. Anyway, so be very careful, guys. Be very careful. Don't help everyone at your expense. You will be in trouble alone. Okay? You'll be in trouble alone. Even a friend, a good friend, once they ask you to take a loan for them because they can't get it and then they will pay through you, or they will decide to abandon that thing. And guess who signed the contract? It's you. So you end up in trouble. So don't, guys. Even in good times, even when people can do it, if they can do it, they must do it themselves. If they can't, then they have to find a way, or at least stop what they're trying to do, because there's nothing that presses them to do it anyway. So they must just stop what they're doing and do the right thing. At some point, people need to be accountable for their own actions. They can't just keep dumping those onto others. As I said, guys, sometimes don't fight the people who double-cross you. Don't fight the people who betray you. There's this thing called karma. This thing called karma, guys, is a real thing because, look, somewhere in the future, we will need each other. Now, be very happy that you are self-sufficient. You don't really need much from others. As much as you can rely on some support, but you don't rely on it, as in you don't depend on it. But those who once needed help to move ahead, they will need help again to correct a situation. People forget that those things happen. So don't double-cross people. Don't go around double-crossing people or betraying people, even when the edge is so, compelling. Even when sometimes the very person deserves a betrayal for some, don't do it. Don't get involved instead. Don't shield anyone, but don't get involved in their predicaments. Let them fight it out. If they survive it, good for them. If they don't, tough luck. Okay? Do when your heart tells you to do it, because your spirit never lies. You will know, even when you're trying to ignore something, something is going to push you inside to do it. If you get that, then do it. But if you want to do it because it's a good thing to do, it's the right thing to do, but there's a voice inside that says no, listen to that inner voice. It must be a no. Painful as it is for you, it must be a no. Okay, now we need to prove that triangle COS, we've just done it, is common. Okay, KAB, okay, that is the other one. So now we want to prove that this small triangle is similar to the shaded triangle. No. It's similar to this triangle. Yeah, this one. Yeah, that's a weak one. It's very, 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 very big, very big. So triangles in triangle. In triangle cos and triangle carbohydrates. What knowest thou about that triangle? Well, we know that C on the cos must be equal to K1 on that one. This is the 10 chord theorem. Right, bekhona into engifuna unibonisa yona kanene. Sendiyilibele futhi noma yintoni. Anywho, it is what it is. Now folks, what do we know again? We also know that S1. Now asikhange sithethe ngayo S1, uyabona ke? Seyanyanzeleka sithi Pratt met distinct. Now we need to talk about it and say why. So S1 is equal to 90 degrees. Why? We know that this is because of the line from center to midpoint of chord. I don't know if I wrote it somewhere, but we're gonna just keep it like so. We can say also, we know that B2 plus B1 equal to 180 degrees. Why? These are angles on a straight line. Please don't say B2 is automatically 90. No, it's not. But B2 plus 90 degrees, which we've proven, is equal to 180 degrees. Only now we can make that deduction that this is 90 degrees. So please guys, do not go around messing around. Don't, especially for a multi-step question. Once you see 4 marks, it already tells us that we are going to have to use multi-step. So we can already conclude here, guys, that, well, S1 is equal to B2. Each is 90 degrees. Therefore, triangle cos similar to triangle carb. Angle. Just need 2. Don't need more. Okay. Now, that statement and reason is good. The statement and reason is good. For me, the last one, this one should be 3 marks. You see. But I do believe proving that this is 90 degrees is okay. It's okay, 4 marks. Now let's take the last one for now. Yo guys, 5 hours. Yo, ndienda libala kuthetha. Phofu ndike ndadriblishwa ila question here. Ke yasdriblisha mos. Yeah, it dribbled us. Now this one is easy but fits. Yeah, again, what's it one? Kamanzi amancane. Kimethi yamanyani. We're gonna use these very triangles. So SO usoso is divided by SO is opposite C. We said C is equal to K1. The side opposite that is AB or BA. Must 2 can be equal to CS. CS is opposite O1, but O1 is going to be equal to which one? It's going to be equal to A. The side opposite A is CK. CK. Now, CK velapingo. Keko CK up. Chini. CS or SC is opposite that. That angle is equal to that. It's going to be BK actually. BK. Again, we can say similar triangles in 11.2 to be exact. All right. Let's see now. cross multiply, we're gonna get so, because minus 2 can be equal to cos plus a degree. Bachelor of Arts yawena ufuna uthini? Now siyayazi ndoba asimfuni lo bhutiza. You are not wanted. Aruhloki. This one is already sharp zinto. But asifuni la BK simthatha phi? Siyayazi ba from the midpoint theorem that we spoke about, this side is going to be double. This side is double that side. Yeah, but from a midpoint theorem. So we're going to say, but we know that BK is equal to 2 times SO. This is the midpoint theorem. At this point, I'll say namdla where's story. Now we can make a conclusion that this implies that OSO times, instead of this one, we put 2SO is equal to CS times BA. Therefore, 2SO squared is indeed CS times BA. Nice question, a nice question. Of course, it's meant to be a suplexity, as you can see. It is a milder form. Maybe it's a power slam or so. It's not that suplex that can break your spine. It's a power slam where we put you nice and easy on the ground. It's just a muscle injury causing pain. Remember, power slam only causes pain to the muscles. Okay. It does not cause anything to the spine, but a suplex, remember, you are already curled up and you are being thrown, so any part that takes the greatest force can snap. So a suplex is dangerous. Power slam is safe. Nice. Okay, all right, 3 marks. Statement and reason, yeah. This one, very much important. Substitution is quite necessary. The final answer was already being suggested, so we are happy. So for this question, guys, we take our 10 marks. Now let's cut it here. It's been too long. I should not have gone for 5 hours, but yeah. This I could have done in 3, actually. Even towards the 4th, but I started talking gibberish, that's why. But remember, during the learning process, guys, you want to take it easy. You want to take it easy. You don't want to rush. As I said, if you rush now during practice, then it means you're hardly going to learn, okay? The key reason for slowing down when you practice is so that you build up the endurance in you, the stamina. You want that flexibility, you want that sharp eye, that quick brain to think. But remember, you're only going to prime it over and over again before it becomes a quick thing. And the brain is one magical instrument. It actually speeds up on its own. It doesn't need you to force it. You just have to slow it down. It's already quick by nature. The brain is supposed to work in an instant. Think of when you want to move a finger. Just the thought about it, and automatically the finger has moved. But once the brain gets injured, you need to train the finger, the muscles to become flexible. That's the purpose of physiotherapy. It's try to make the muscles responsive, flexible, not stiff, the joints to get used to moving. The brain is trying to figure out now through some other pathway how to do it, and you will see that it will be slower, but it will still be present, but it won't be as quick as it was because the brain got injured. So the brain is able to figure out if you help it out. It eventually comes to the part. Okay, guys, this is it. Leave the video the thumbs up it deserves. Don't be stingy with that thumbs up. I mean, come on, guys, it's just a click. even if you didn't watch this video, just look at it, click like, and then bye, go away, thank you at the same time. You will not be, you won't lose anything for doing that, but you are helping other kids. Remember guys, it may not be relevant for you, but it's relevant for somebody else. And it takes you liking the video for the video to even become more visible and become suggested to others. Because the more likes a video gets, especially early on, then the algorithm figures out that this is important. So anyone who has, or at least has watched a video similar to this, it will be suggested to them. And guess what? What if it's what they need? So please guys, don't be selfish. At this point, this one you must do. Okay? You must do. But be careful though of helping people where you have to lose something. Yeah. If you're gonna lose something, don't do it if you feel like not doing it. There's nothing wrong in not helping. So don't be blackmailed by the fact that you have the resources, maybe. But if your heart says no, there's nothing wrong in not giving. It's like in church, guys. It's not a must that you should, offer something. When it's time for offerings, even if you have money in your pocket, if you feel like not giving that offering, do not give it. Because that's not what God says. God says a willing heart must be your motivation to give. Now, if you're already feeling forced, so some church members are telling you, why unikela udokotela unikela nge-20 rand tyhini kanti abantu banjani yobastingy, they are playing God. Leave them to talk nonsense. They don't know what they're talking about. God knows why you are giving 20 rands. You don't even need to explain to him. They don't know. But one thing for sure, if you have a family, guys, you cannot let your family starve because you want to take your money and go and impress church members. That's not an offering for God, because your heart is already not happy. You are stressed. Where will I get the money for my kids? Where will I get the money for my siblings, my brother, whatever? Where will I get the money for my car? Look, you look after yourself. God gave you that ability to be able to hold a job or to have some money or allowance, whatever it is, so that you can look after yourself. Do it. Remember, that body of yours is his temple. Now the temple must be clean, must be well looked after. You need to feed that body. Don't be ashamed to feed the body, all in the name that God must do it himself. Come on, it's like you're daring him. You're actually disrespecting God if you expect him to come and do it for you. If he gives you means to look after yourself, do it. That's the first thing that you should. Then you look at those around you. If you can carry them on your shoulder, do it. But if you can't, don't. None of those people are your problem. Believe me when I tell you. Everybody is given a chance in life. If they don't take it, it's not your problem. But if you can and you want to help, do it. But if you can't, you don't blackmail yourself with that. God will always have a plan for his children. But you have to make sure, though, that you look after this person that you are. Now, once everything is fine, mntana enkosi, child of God, if you are all good, you've paid your debts, you've gassed your car, you bought your clothes, you bought your groceries, you paid your school fees, whatever you're doing, you've fed them at home if you want. Now you have money left over. Okay? Now you see in church, oh man, there's this big event. And you know that, okay, I have an extra 5,000. I don't know what to do with it. And before you waste it. Now, here's the thing. If you have money left over, the first thing to do, guys, is to save. It's not to spend. If you see there's money left over, rather save it. Because there will come a time when even the job that you have is not enough for your needs. That money that you put away might just be the difference to protect you from stress and depression. These things are real, guys, and they hit everybody. Save it. And of course, if you think you've saved enough, maybe you said, okay, a month I want to save 5,000. Now there was this 7.5 walking around. You've put your 5,000 and you're happy. Then you can take that 2.5 and go and give it as an offering in church. God is fine with that. Don't listen to people who are going to blackmail you to give your only money in the name of pleasing God. God is not pleased by someone who does things that they are forced to do and who doesn't even understand why they are doing those things. The offering says there must be food in the house of the Lord, and the purpose is because He wants those who are suffering in the church to be looked after with that money. It's not for the pastor. It's not for the committee of the church. It's not for, whatever these people do with the money. The offerings, guys, are for all the church members, especially those who do not have much and they are here. The reason is that God doesn't want a sob story in the church or a sad look in the church. So the church must use the money for offerings to look after the poor. If there is no one who is poor in that church and everybody is blessed by God, as sometimes people say, then it means that church must look after the community. There's people who don't come to church but have nothing. The church can make up a plan to look after those. It can be food parcels every month because the money is generated. Of course, you will look and see how much money do we make on average every month. From there, you look at an amount that you can use for a certain few houses that can be identified. And there has to be fairness in this. You cannot do it this month, then the next month you're not going to do it. If those people still don't have much, you look after them. Those people might be the very ones that you need tomorrow when you run into a problem. That person being healthy and well looked after by your church or by you through the church might just be the person who saves your life from an attack by authorities. You never know. Or something gets really, really, really bad for you and that person lifts you up. So don't do things always expecting a return though. But you never know. You never know. So all I'm trying to say, don't be forced to give a tithe in church. It's not a must. No. Don't listen to anyone who makes it look like that. And they will blackmail you to paying money that you don't have. All in the name of pleasing God. God doesn't care to be pleased by you. We fool ourselves by thinking we please Him. God wants us to respect Him. And respect is not necessarily pleasing someone. God wants us to listen to Him. And to do so is not necessarily to please Him. He doesn't get pleasure from anything that we do. But He gets pleasure when we are fine. We're looking good. Think of yourself also. You don't get any pleasure in going to plow the fields, fix the yard, paint the house. It's painful. Sometimes you don't want to do it. But you realize after you've done it, when you come from a distance, you look at that house, how well you've done it, how good it looks. It now becomes the prize inside, the joy inside. Even when your fields now have blossomed, your mealies are nice and healthy and you can see isikhwebu phayana uba hey siyakhipha ngoku yazi banzothola isivuno esihle. You see, the marvel is not necessarily at what it is that you see, but it's how it is that you see that gives you the marvel. What it is, it's part and parcel of it all, but how it is more important. It's what is more, what gives joy. Uba nomntwana, yes, it's nice, but umntwana oyinjubaqa is not a blessing at all. It's a curse, by the way. And whatever you can say, sub-stories to try and color code it, there are certain such children who are not a blessing at all, but were nothing but a curse. And you will see that it is so. Because unprovoked, they become a nightmare for their families, unprovoked, where there was no witchcraft from outside or whatever, or someone doing it or pushing them. Unprovoked, they become a nightmare. What would you call that? A blessing? Never. Stop playing things here, guys, trying to sound right. Be right. Don't sound right. Be right. And you're not always going to be. Not everything's always going to be perfect. There's hardships. There's tough times. There's bad things. There's mayhem. There's pain. But do you know what makes you survive all of these things? Is understanding that in life you can only do so much, guys. The rest will have to figure itself out. You know, there was a song by Dolly Parton. Is it Dolly Parton? It says, "Here you come again." I like the lyrics of that song, but I can't play it all on my piano, but I can try. But my piano needs service, you see. Some notes are not nice. So it starts like this. I always miss this part. I forgot it. Oh my God, this song is so nice. I like it when there's a bit of strings in there, but I can't sing the buffet. Do not even think about it. Conche, which one do I use? EP or XD? So here you come again, just when I've begun to get myself together, you waltz right in the door. I forget this one. Just like you've done before, and wrap my heart round your little finger. Actually, it's just talking about some form of a disturbance. When you are thinking that you've done it all well, you've become good and you've been fine, here comes the tsunami that left you in shambles. It comes again. Anyway, guys, live a good life. Live positively, of course. Don't be negative. There's no need. But there are moments where you have to be negative. Just remember that. If it is for a good reason, you have to be negative. And if it's not for a good reason to be good, you must not be good, okay? Fact of the matter is, let what you do be goal-directed and purpose-driven. Ndiqibile, guys. Ndizonibona kwixa elizayo. Khona ntini kuba kusebusuku ngoku.